Hello, students. Okay. Hello, students. Hello. Hello. Hello, students.
Yes, ma'am. Now it's streaming live on YouTube. Okay.
Okay, sir. Thank you. Hello. Hello. Unmute करा.
खोब्रागडे मॅडम मी तुम्हाला होस्ट करून देतोय आता.
हो सर.
तुम्ही बाकी लोकांना को-होस्ट करून द्याल मग नंतर.
हाँ सर ठीक है.
स्पीकर्स असतील त्यांना.
ओके सर ठीक है. हेलो. हेलो स्टूडेंट्स. Hello students, can you hear me? Hello. Hello students.
Yes, ma'am.
Hi. Okay. Hello students.
गुड मॉर्निंग. आरती तुला माझा आवाज येतोय? आरती, रेखा,
हो सर.
अल्मास, क्लिअर आहे आवाज?
येस सर.
हा, आपण 5-1 मिनिटात 11 वाजता बरोबर शार्प 11ला सेशन सुरू करू. आपले गेस्ट जॉईन होतील 11ला. तुम्ही 5 मिनिट रिलॅक्स राहा. ओके.
ओके.
Hello. Hello.
Yes, sir.
Hello, Anand Alay.
Yes,
Join.
sir. Yes, yes, sir. Actually,
हाँ.
Wilson College ID
हाँ.
में join किया. Yes, sir. Yes, sir.
Okay, okay. चालेल.
Sir, just give me 1 minute, sir. Just 1 minute.
Hello. आनंद, तुला माझा आवाज येतोय?
आईडी में ज्वाइन होता है ना पंडित सर.
Hello everyone. Am I audible?
Yes, sir.
Yes, sir.
Anand, are you comfortable?
Yes, sir. Yes, sir. No issue.
So, dear students, it's time to start the second day of this workshop. I, Dr. Prashant Mandlik, convener of this workshop, along with organizing secretary, Dr. Vyas Thakre, and committee member, Dr. Vandana Khobragade, and Ms. Rakhi Bankar, we welcome you all for enjoying second day of this workshop. Online today workshop on CSIR NET-CET examination is for postgraduate students offering chemical sciences, organized by PG Department of Chemistry, Shivaji Science College, Amravati. Yesterday, on the first day of workshop, the workshop is inaugurated by Chief Guest Dr. F.C. Raghuvanshi Sir, Dean Faculty of Science, Santa Gadge Baba Amravati University, Amravati, in the presence of Guest of Honor, Dr. A.S. Aswar, Professor and Head, PG Department of Chemistry, Santa Gadge Baba Amravati University, Amravati. The function was conducted under the chairmanship of Dr. G.N. Chaudhary, who is officiating Principal and Head, Department of Chemistry, Shivaji Science College, Amravati. Before we get started for second day, I would like to remind you the purpose of the workshop. The purpose is to motivate the students to opt for NET-CET examinations, to know about the syllabus of the examination, to upgrade the knowledge, to understand the plan and strategies towards the preparation of NET-CET examination, to solve the problems from previous examinations, to interact with the expert faculty members in the field of chemical sciences who are actually involved in the process, and to plan systematic study and perfect time management to save time and the efforts of the student. To follow the purpose of the workshop, we have invited eminent guest speakers who were able to fulfill the requirements. Yesterday we had two eminent speakers, Dr. Manish Rao sir. He is assistant professor in Department of Chemistry, Modern College Pune, and director of R&S Academy for CSIR NET SET GATE Chemical Sciences Pune. He has nicely introduced the participant to various aspects of NET SET examinations, and then he delivered a lecture on the topic stereochemistry. The second session was enlightened by Dr. Vikas Kadu, who is assistant professor in the Department of Organic Chemistry, School of Chemical Sciences, Punyashlok Ahilyabai Devi Holkar, Solapur University, Solapur. He delivered his talk on NMR spectroscopy. Today, on the second day of the workshop, we have again two eminent speakers with us. In the first session, Dr. Anand Gurange, who is assistant professor in Department of Chemistry, Wilson College, Mumbai, going to deliver a lecture on the topic reagents in modern organic synthesis. In the second session, today's second session, we have with us Dr. Bapurao Singte, who is associate professor, Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. He will deliver a lecture on the topic multi-step organic transformation. Let us move towards the first session, today's first session. Before to start the session, it's my duty and proud to introduce you today's guest speaker, Dr. Anand Gurange. Dr. Anand is the alumni of this college and one of our best students. Dr. Anand has completed his graduation in 2006 from this institution and master's from Government Vidarbha Institute of Science and Humanities, Amravati, in 2008. Later on, he has completed his doctorate in 2013 from Institute of Chemical Technology, Mumbai. He has both academic and industrial experience. Presently, he is working as an assistant professor in chemistry at Wilson College, Mumbai. He is a visiting faculty of Ram Narayan Ruia College, Mumbai, in University Department, University of Mumbai, and in Institute of Chemical Technology, Mumbai. He is the fellow of CSIR, fellow of various fellowships. He has CSIR Nehru postdoctoral fellow at National Chemical Laboratory, Pune, during 2015 to 2016. Research associate at NCL, Pune, and assistant manager, research and development of Johnson Matthey Catalyst, India. Dr. Anand has received many prestigious awards such as CSIR Nehru Postdoctoral Award in 2015 by Council of Scientific and Industrial Research, CSIR Research Associate Award in 2015. He qualified all India examination in chemistry, that is National Eligibility Test, NET and GATE. He has also received Dr. P.J. Deshmukh Memorial Medal towards the appreciation of merit for outstanding achievement in BSc degree. He was the 5th merit in MSc in Santa Gadge Baba Amravati University, Amravati. He received first prize during quiz competition in 21st National Symposium on Catalysis for Sustainable Development at IICT Hyderabad. He received Eklavya Scholarship for distinction in graduation awarded by Santa Gadge Baba Amravati University, Amravati. He has number of research papers to his credit in various journals of high impact factor. He wrote chapters in books, namely in Encyclopedia of Nanoscience and Nanotechnology in 2019, Encyclopedia of Inorganic and Bioinorganic Chemistry in 2016, Advanced Heterogeneous Catalysis Volume 1, which is the application at Nanoscale ACS Symposium Series 2020, and separately he has published books on heterogeneous catalysis and reviewed various chapters in the books. Dr. Anand attended various international conferences and worked as a referee for various research articles. As the listed journals are Natural Scientific Reports on Springer, Organic Letters, Journal of Chemical Technology and Biotechnology, Ilion, Elsewhere Journal, and Catalysis Letter with Springer. Combinatorial chemistry and high throughput screening, Bentham, research on chemical intermediate Springer, molecular catalysis Elsewhere, polycyclic aromatic compounds Taylor and Francis. Dear students, this introduction of Dr. Anand reflects about his personality. He is a good researcher, and I am proud to say that he is a good teacher also. Thank you, Dr. Anand, for accepting our invitation and join these students. Finally, I request Dr. Anand to start with his lecture and guide our students for the preparation of NET/SET examination. Please.
Thank you very much, sir. Yes, sir. Thank you very much, Mandlik sir, for very much elaborated introduction. I was not expecting everything to be shared, but anyway, thank you very much. And I am very much honored to be part of this workshop NET/SET activity. And as an alma mater from Sri Shivaji Science College, I owe you a lot, and teachers always inspire us, and we must not forget that from where we begin. So my beginning in chemistry field started at Sri Shivaji Science College, where Mandlik sir was everything for me there when it comes to chemistry. And I tried to learn many things, and the story should not end in between. We should continue the thrust of getting knowledge. Before moving to the session, just I want to share a few things about the NET/SET examination, and it's kind of a craze that who has qualified NET examination or GATE examination, and how many times you have qualified the examination. My personal opinion, first you should understand why there is NET examination or GATE examination. These are just eligibility criteria. Eligibility criteria, if you qualify NET exam, the eligibility criteria to get into academics for the post of assistant professor at entry level. And if you qualify JRF, it's eligibility criteria to get into research at various research laboratories. We have 40 plus CSIR laboratories and other laboratories. So that is the criteria. So you should not be, one thing, you should not get overconfident if you qualify NET, and you should not get underestimated if you don't qualify NET, because any examination does not judge your talent. We heard of many people, those who, they are topper in universities, but what they contribute in the future, that's matter. We have to be the part of the game for long run, and it's a long race. If we are alive, then we should keep contributing, and that is my expectation. And the second more thing, that is my perception. Everyone has a different opinion, different perceptions, and I respect everyone. But as I am invited here, I want to tell you, I do not believe in the tricks mix. Okay, what is the trick to understand? If you qualify exam, for example, NET JRF, by some trick, and then you have to do research, and no trick work there. It need hard work. It need your own understanding, because India right now, yes, we are growing in chemical sciences, but particularly organic chemistry, what is there today, it is altogether different. Now I'm sharing screen, sir, and before moving to reagent part, few basics are there, but I will not spend that much basic, but we should understand, first of all, reactive intermediate. Please tell me if the screen is visible. Sir, is screen visible?
आनंद
Sir?
हाँ स्क्रीन शेअर होते Visible or visible?
Share is, can you see everyone? Yeah.
Yes, sir. Yes,
Yes,
sir.
Okay. Now just quickly, one thing I want to share with you. This is one of our work that on Suzuki coupling. It is one of the highlighted in ChemU magazine, and it is also highly downloaded article, and it was also part of Wiley Hot Topics because we tried to give a new mechanism for Suzuki cross coupling reaction. And right now, the science is interdisciplinary. It is not just organic chemistry. Especially Amravtikar and the students in the Vidarbha region, we have one issue with us that I am organic, I am inorganic, I am physical. But right, if you look at the research, what is going on today, everything is interdisciplinary. Okay, we have to use materials, we have to do the characterization, we have to check their physical properties. So there should not be a boundaries of inorganic, organic, and physical. When it actually comes to any good research laboratory, then you will realize the difference. And we should be able, after qualification of NET exam, you should know one thing, because I was very stupid those days. I was thinking that I will do this work. Okay, so it is not like that. We first, after qualification of exam, we have to go to different research laboratories, apply there, and then we have to give the priority to the research guide for the PhD program if you want to go. And then we have to work in their area of interest. So it is not possible that what you want to do, that you will get it. Okay, first of all, you should get the proper training, and you should get streamlined that how to get start your own idea. So PhD is basically it's a training program. So now I go with the reactive intermediates. So there is a difference between reactive intermediate and the reaction intermediate. If I say reaction of alcohol, and I'm doing oxidation reaction by using strong oxidizing agents like potassium permanganate, or say alkaline potassium, potassium permanganate, or acidified potassium dichromate, then you can see that your final product, your final end product is the carboxylic acid. But if you stop the reaction in between, you can see, you can quench the reaction, you can cease the reaction, and you can analyze the product, and you may get the aldehyde. That is the intermediate which is formed during the reaction. That is called as a reaction intermediate. But when you look for the reaction mechanism, okay, generally what we get the curve in the energy profile diagram of SN2 reaction. It's a concerted mechanism. So concerted mechanism, you don't see any valley, any intermediate form there. But if any intermediate form out of these, whatever shown on the screen, then you can see valley. There may be one carbocation, there can be two carbocations, there can be more intermediates. On that basis, number of intermediates varies with respect to reaction, what reaction we are looking for. So we have carbocation, carbanion, carbene, nitrene, radical, and arine, and there are these intermediates are involved in many reaction mechanisms. Now one thing which is there are a lot of discoveries, and most of the discoveries are serendipity. And when we use word serendipity, so serendipity means accidental discovery, and accidental discovery doesn't happen to everybody. We need personality, we need a person who is methodological, who is critical thinker. Then only he can analyze, or she can analyze his or her mistakes, and then something can happen. Now carbocation, it is also a serendipity, and it was by George Olah. And many of our textbooks still contains the carbonium ion as a word. But when the IUPAC said that the word IUM should come if the valency increase by 1. For example, water, in which oxygen is a central atom, it forms 2 bonds, but when it forms 3 bonds, it forms hydronium ion. Nitrogen valency is 3, when it forms 4 bonds, it forms ammonium ion. But when carbon forms 3 bonds and acquires positive charge, then also we call this carbonium ion. In 1987 only, this final judgment came about, regarding that. But when I was in college, it was not corrected. I don't know what's the situation there, but this is the story. So when I should use word carbonium, if carbon valence is 4 if it forms a 5 bonds. So CH5 species is a carbonium ion, and even this species was identified, for your information. So George Olah found this CH5, it's also called as a methanonium ion, and it's actually carbonium ion, and he published his work in 1971. Okay, and he started long before. A few people already tried in that area, and now we know the stability of the carbocation. So when I say a carbocation, it's generally it's sp2 hybridized, where 3 bonds are trigonal planar and 1 orthogonal vacant p orbital is there. Okay, and we know that the tertiary carbocation is more stable than secondary, primary, and then methyl. The reason behind it is hyperconjugation. You should not say electronegativity. Okay, so hyperconjugation is the effect, and in Jerry March you can read about it. There is something called as a Baker-Nathan effect, which proves yes, this work. Now, can we form the carbocation? Yes, we can form carbocation also easily. How to do it? So answer is a superacid. For example, if you take this fluorosulfonic acid and SbF5 dissolved in liquefied sulfur dioxide or their relative components with halogen, then the acidity of the material is very high. Okay, and this material, this superacid, are too much acidic, they can even abstract the hydride from the carbocation. You can see this is the work of 1967, where you can see 4 carbon containing alkane, and when it is treated with the superacid, you can even get the carbocation. So whenever we say carbocation, any positive charge or any negative charge cannot be there. It should be with some counter ion with it. So you can get the counter ion, that is this remaining species. Okay, so positive charge is satisfied by negative charge. Now this work was published in one of the good American journals. So we can synthesize carbocation in the laboratory by taking, but we need a specific reaction conditions to apply. So even the fluorides can give you carbocations. Okay, so so these are different way, because we are removing fluorides by using antimony pentafluoride. Okay, now these carbocations, when the study was going on, then they observed that if you take even N-propyl or isopropyl, both are giving isopropyl carbocation. And if you look at these 3 sentences which I have given here, this was the clue to tell about the stability of the carbocation, how we understood why which is more stable, how the theory is generated. These are the experimental evidences. For me, there is no theory. Theory comes into the literature only after the practical, and when we have enough experimental evidences so that somebody can easily generalize it, rewrite it into the lucid language so any new beginner can read, then we call it as a theory. But theory cannot be there if there are no evidences, nothing practical. Now there are some other carbocations also. We know that the allylic and benzylic carbocation, we know their canonical forms. More the canonical forms, more is the stability. But we must know during the reaction mechanism, there are something called as a non-classical carbocations. Okay, where cyclopropyl kind of species, even the sigma bond can stabilize this carbocation, which are known as a non-classical, and their stability is extraordinarily high. So we can see the vacant p orbital of carbocation interact with the sigma bond electron, and it imparts or it gives a very high stability to the positively charged species. So this is the another important part, and you have to take care when you are writing down any reaction mechanism. Now acyl carbocation is also very much stable. You can see, you can even get this kind of the species. So there is something known as the resonance form, so that it increases the stability, and even it is more stable, not more stable, but as stable as tertiary butyl carbocation. Then there is one more important rule, I hope all of you know, that is known as a Brett's rule. Now you can see, when I say a carbocation, the carbocation should be planar. It should be the trigonal planar geometry. If by some means that planarity cannot be achieved, in that case such carbocations do not form. So if I say the simple Nor-Bornean system, this is little larger size system, and this is again larger size system. So if it is a Nor-Bornean system, this structure cannot be planar. If you take the molecular model, if you order it, or if it is in the college, if you try to make it, you can see it cannot be a planar. If it is not planar, it will not form at all. So this is the simple thing that is known as a bread rule, where you can compare in the NET examination. They may ask you the rate for SN1 reaction or rate of SN2 reaction. So at this place where my you can see my cursor moving or pointer moving, at this place SN1 is not possible because that carbocation does not form at all. So there is a simple clue. So we have to choose the right option with respect to that. So they exist in the generally in the ion pair. Do you think that commercially carbocations are available? People say yes, carbocations are highly unstable. They have very short Lewis spaces, but non-classical or some carbocations which are sufficiently stable, they are in the market. You can take that. So what is that? It is triphenyl carbocation and its counter ion is BF4 minus. It is commercially available. Okay, this is one thing you should know. Okay, so you have to think beyond what is there in the textbook, see the reality, and we are in 2021. Then there are certain carbocations. Suppose if you look at the benzylic carbocations and there are different groups, then electron donating group and electron withdrawing group have the different effects in the stability. Okay, so we have to see when the carbocations become more stable, when the carbocations become less stable. That is the another part. Okay, now this is the simple problem. We'll start with the first very simple problem. Then I may go to very complex things here. How will you synthesize N-butyl benzene? Can anyone want to share from the group? Anybody can just give me quick answer that how will you prepare N-butyl benzene? Anybody? You can write in the chat box.
Friedel-Crafts alkylation.
Okay. Any other answer? Okay, Sanket said Friedel-Crafts alkylation. How many of you, Sanket said, yeah. So how many of you believe that the Friedel-Crafts alkylation is the right answer? Do you agree with the Sanket? Anybody at least give response in the chat box. See, when you become wrong, okay, then you learn more. If you are
Excuse me,
always
sir.
correct, yes.
Friedel-Crafts alkylation followed by reduction.
If you do alkylation, there is no need
No.
of reduction.
Firstly, Friedel-Crafts acylation and then
Yeah,
reduction of it.
Yeah, so Friedel-Crafts acylation is the right answer, not alkylation. When you alkylate any aromatic ring, why not Friedel-Crafts alkylation, Sanket? If I take 1, 2, 3, 4 N-butyl chloride and carry out its reaction with aluminum trichloride as a catalyst, okay, with benzene, what product you will get?
Secondary carbocation will form and the resultant product will not be obtained, sir.
Yeah, so that you will get the isobutyl benzene, that is one. Then again, compared to benzene, the isobutyl benzene will increase the electron density on the ring and there will be a polyalkylation, so it will not stop there. So there are a lot of problems. Okay, so Friedel-Crafts alkylation, as we have seen, and even the George Olah observed the rearrangement of the carbocation. So of course, we can go with the Friedel-Crafts acylation. Okay, and then we can do the reduction. Either we can do the Clemenson's reduction or the Wolff-Kishner reduction. Now this is the simple reaction. What do you think? What is this? So carbocation rearrangement is there. What do you think? What product would be here? It's very simple. Then I will go to the complex part. What do you expect? This is tertiary butyl and this is methyl. So it's a neopentyl alcohol. And if I carry out neopentyl alcohol with acid, what product do you expect? Acid means you should ideally put H3O plus. Okay, but it's a concentrated acid. Okay. See, we should know one thing, that if anywhere there is a alcohol and you are putting acid to it, the oxygen with the two lone pairs, it easily get protonated, and you may get the primary carbocation which is not stable at all. So it can rearrange, one of the methyl group can migrate here and you may get the tertiary carbocation. So when you are using the anhydrous carboxylic acid, in that case, so anhydrous mineral acid, in that case the dehydration is favored and you can get the alkene. This is important part that one should know. Okay, then in N-butyl benzene synthesis or any alkylated benzene synthesis, you should also know because nowadays there are also questions with respect to materials in the NET examination in some section. For example, the aluminum trichloride. Generally, when we use a catalyst, we use in very small amount. We don't use in the large amount. But if you say aluminum trichloride, it is used in this stoichiometric amount. It's used in a very large amount. So when you do the workup, there is a tons of aluminum waste is there. Okay, it get hydrolyzed in the quenching, and that's the problem. Okay, so we are replacing that by newer way. We are developing the new solid acid catalyst. Okay, and trying to replace this kind of the Lewis acid. Okay, now I will quickly go to another one. These are certain certain examples of the Wagner Merwin. Can you write down the can you try the product of it, anybody? I will quickly share another screen. Just a moment. Okay. I will quickly take this example. Please tell me if screen is visible. Okay. Can you see the screen?
Yes, sir. Now it is visible. Yes.
Now this is a typical Nor-Bornein system. Okay. Now we know that the carbocation formation is not possible at this position. I will just here the carbocation is not possible. Okay, so actually this is the bridge. Okay, suppose I want to come from here to here. Okay, so this is a typical Nor-Bornein structure, and if I look at this species at the at three-dimensional way, I can see it cannot be a planar. Okay, but any oxygen atom, okay, it has two lone pair, and it get easily protonated when it comes in contact with the acid. So obviously in the next step it get protonated, and if it gets protonated, the oxygen will bear positive charge, because one lone pair is now used in protonation. Okay, so there comes a positive charge. Okay, and in the next step the water molecule can be departed easily to form a carbocation. So what species you will get next? So you will get a carbocation not at the short position, at adjacent position where the carbocation is possible. Okay, if I look at this carbocation is attached to two carbon atoms, so it's a secondary carbocation. Okay, but imagine one of the methyl group, this CH3 group, migrates over here to this carbocation. So migration is always taking place. The group moves with the two electrons or the bond pairs, and you will end up with another structure. So what structure you will get? You will get another structure. One group is migrated now, and you get another structure, and positive charge will come here. So when I say acid catalyzed mechanism, so in acid catalyzed mechanism, catalyst is always leave the system at the end of the reaction. So suppose here is H. Okay, so there is in the these are line structures, and in line structures we do not show the hydrogen generally. So since acid H plus entered the system, it must leave the system. So H plus will be departed. It will depart. It will give its electron density. So there is additional pi bond formation. So what are you getting now? You get the another molecule. It's your final product. this alkene you get in the Wagner-Meiermin. Is it clear to all of you? Hello?
Yes, sir.
Okay, so now again I will share the presentation. We'll again go there. Okay, so the product, what we expect here, these are these different products. You can take the snapshot and practice the mechanism without practicing reaction mechanism. Okay, it is not possible. For organic chemistry, we must practice everything. Okay, so organic chemistry, every part of chemistry, physical chemistry, their derivation, okay, or any equations, we have to practice it and then also understand it, not just practice, understand the orbital approach. That is at the next level that we can consider. Similarly, this is the very famous reaction known as a pinacolone rearrangement, where typical a diol, okay, undergoes reaction, okay, and you get the product. Okay, so there are different products possible, but how to decide if the diol is symmetrical, then there is no problem in the mechanism. What if the diol is not symmetrical? Okay, and what product do you expect in this case? So I am sharing screen again with you. What we have to imagine there? Just give me time, just a minute. Okay. Is screen visible?
Yes, sir.
See now, if we have a diol, okay, and there are two different hydroxyl group, then there is a competition that which hydroxyl group will get protonated. Are you getting me? Okay, now in pinacolone rearrangement, always choose that hydroxyl group which will lead to formation of stable carbocation. If the carbocation forms here, OH will depart as a water after protonation, you get the tertiary carbocation. This is also tertiary carbocation. Now tell me which tertiary carbocation is more stable. Anybody? You can write in the chat box. Which tertiary carbocation is more stable, left or right in on screen?
Right.
Why? Yes, because
Two phenyl groups are attached.
yes, two phenyl rings are attached, and these are not just two phenyl rings, they are also the carbocation is benzylic. So obviously, if it get protonated, okay, so this if this species will get protonated OH2 plus, okay, then when it departs, you get a stable carbocation. Okay, so what is that carbocation? You have now two pH ring. You got tertiary as well as benzylic. So you get this carbocation. In organic reaction mechanism, wherever there is a possibility to form a carbonyl group, it always preferred, because carbonyl group has more bond energy, and definition of bond energy said minimum energy required to break the bond. So always this is preferred, and if there is a possibility to form C double bond O, okay, then it also happens. Now oxygen has two lone pair, and in mechanism, always if there is any possibility to form the carbonyl, it always happens. So here, if this oxygen try to form a double bond with this carbon, carbon cannot be pentavalent, so one of the group of either this CH2 or this CH2 migrates. If it's symmetrical, then it's fine. If it's not symmetrical, then we have to look for the migratory aptitude, and in the migratory aptitude, generally the group with more electron donating group is migrated. Okay, so imagine this group migrated. So what is going to form here? C double bond O, and 1, 2, 3, 4, 5, 6 carbon containing ketone. Okay, and on its, okay, and next to that carbon you will have two phenyl ring. Okay, so this is the product. Okay, so similarly, so we can write down the product. So what is the product now? We can have C double bond O and 2 phenyl rings are here. Is it clear? Hello, you understood this part?
Yes, sir.
When you are, there is something called as a semi-pinacol pinacolone. This is another one of the reaction where the reagent used is tosyl chloride. How many of you know the structure of tosyl chloride? At least say that. How many of you know the structure of tosyl chloride?
MI, sir.
You know?
Yes, sir.
Okay. What is tosyl chloride? Can you tell us?
It is a chloride product of para-toluene sulfonic acid.
Yes. So it is para-toluene sulfonic acid is there. It's a chloride. It is. So Me phenyl ring and SO2Cl, S double bond O Cl. Okay. So that is a tosyl chloride, and this tosyl chloride, where is tosyl chloride is used? So tosyl chloride is used to form or make the OH group labile. Okay. For example, OH group can make labile by protonation, where you can form the carbocation. But other than that, you can make it better living. Labile means better living in another approach, or the basic approach. So basic approach uses the use of the tosyl chloride along with the base. Suppose we have a pyridine as a base here. Okay. Now always remember, when you are dealing with the tosyl chloride and it is a very big structure. Okay. Always the alcohol which is means not always but often the alcoholic group which is primary is preferred over secondary, secondary is preferred over tertiary. So if I have this 2 OH, I give the color code now. Suppose I have one OH here red and one OH blue, so which will be preferred? Red and black, which will be preferred?
Black.
Yeah.
Black.
So what happens? It attacks on the tosyl group and you end up with the better living group, that is OTS. Okay. Then again, we have the same mechanism as I said. Wherever there is a possibility to form C double bond O, the carbonyl group will always try to form the bond. When it try to form the bond, okay, since again these two groups are identical, any group move here and it is a bit, since tosylate is a better living group because the charge can delocalize, S double bond O minus, it's a better living group, and you get the 7-membered ring, and that 7-membered ring has a carbonyl group. So this is how you can get the another product. Similarly, tell me where the tosylation takes place in this case, in this structure. I will give color code here. Again, the red and blue, for example, where the tosylation will take place. Red or blue?
Blue.
Blue.
Yeah, because it's a secondary. Okay, it get tosylated, it become OTS. Again, oxygen lone pair will try to form the bond C double bond O, but carbon cannot be pentavalent. So now we have the two different group. Okay, suppose I am showing it two different groups can move. Now here it is little tricky. Okay, just a moment. Where is the color? Yeah. See, now you can see bonds here. I give color coding to the bonds. This is a blue bond and this is a red bond. Now which bond will migrate? Suppose if it is a C double bond O will form, okay, OTS will form. When the oxygen will try to form bond here, this group will migrate or this group will migrate? The group from the red carbon-carbon double bond or carbon-carbon single bond, which will migrate here in this mechanism? Anybody? See, the carbon-carbon double bond has a more electron donating power. So it will always get migrated and you will get the related structure. Now, before moving ahead, I have one question. Should I continue? Should I go to the tougher level or should I come little down? I can just switch to the examples. I just need a student's quick response so that I can decide the next part. Anybody? Student, please respond what to do now. Because I am going to tell you now what current trends are there. Because right now, if you look at the NET examination, they are not asking questions from the textbook. If you look at 10-15 years back NET examination, then obviously the resources were limited, but the examples were from the book. But right now, if you look at the examples, they are sharing, they are asking the questions from the research papers, recent trends. So generally, I want to share you one research journal that is known as Organic Letters. Most of the problems are coming from either Organic Letters or Journal of Organic Chemistry. Okay, so there are the different methodologies are coming in that. So I am at the end of the session, I am going to share that also. Mandlik sir, I just need a response, sir. Kai karaycha? Should I go ahead? At least students should respond so that I can decide next 1 hour strategy.
Student, please reply, sir. What to do?
Yes, sir, as you wish.
No, not as you wish actually.
What actual students want?
We want tougher one, sir, as you have said about research papers.
Okay. That is only you, I guess. What about others? Yeah, so we have to keep the balance also. Okay, tough, more tough. Okay, intermediate level. Okay. What I will do, I will quickly go through a few intermediate examples. Okay, and then I may move to the another one. I will tell you that what to do. Okay, just give me 1 minute. 1 minute, I will join. Okay, hello, am I audible?
Yes.
Okay, those who are preparing now, what means just started the preparation. For them, I will spend next 20 minutes, and maybe last half an hour I will discuss some more tough problems. Just tell me if screen is visible.
Yes, sir.
Just a moment. Okay. Okay, screen visible.
Yes, sir.
Okay. Now see, this is a very simple reagent. Those who are preparing right now or they started recently, this is a simple sodamide. Okay, there is one concept known as a solvation of electrons. Even electrons can get solvated when it comes to ammonia. Okay, the ammonia gas is liquefied, then only you can see the solvation and you can see the beautiful coloration there. So generally, it is a benzene mechanism. There is also the terminology known as a sign substitution, CINE. Okay, what is that about? Generally, if we have any chlorobenzene, this base is so much stronger sodamide, it can even abstract the orthohydrogen, and when it abstract it, it forms this intermediate, benzene intermediate. If it is substituted, we call it as a arine. And imagine we did some radio labeling here. Suppose we have a C14 here, then you can have the two different products possible. Maybe the NH2 is attached to the same carbon atom or to the adjacent carbon atom. Maybe C14 carbon is here or here. So likewise, the two products, if you radio label it, that is possible. The benzene is favoring the attack of the nucleophile, though it is looks like the carbon-carbon triple bond, but it is not actually, it is not electron rich, and people do the mistake, and it is the electron deficient species that we must understand. Then there are certain examples where if we have orthodichloro, meta-dichloro, or para-dichlorobenzene, and you do the same substitution with the sodamide, then what product you get? So there is very simple, you can remove any orthohydrogen, you can relocate or rearrange the pi bonds in the benzene ring, choose any carbon chlorine bond, and you abstract the orthohydrogen and prepare benzene first. And the moment you get the benzene, then you do not forget that the chlorine, when halogens are present on the aromatic ring, they are deactivating. So people get confused with the deactivating and electron donating. So deactivating means for electrophilic aromatic substitution, it is difficult. You need a stringent reaction condition to further do the electrophilic aromatic substitution. But at the same time, chlorine has a lone pair. When the halogen form only single bond, they have 3 lone pairs. So they show the plus R effect, giving electron density to the ring. So if you have the benzene here, then it gives the electron density to the ortho and para position. So amide as a nucleophile cannot attack at the center which is electron rich, so it always favor the electron deficient center. Okay, so that's why in all the cases you get the metachloroaniline. Understand this part? So always see, even after you prepare the benzene with one chlorine, you focus on the plus R effect of remaining chlorine atom. Okay, avoid ortho and para position with respect to that chlorine, and you will analyze that even if you suppose I want the metachloroaniline, I have the mixture of ortho, para, and metadichlorobenzene. I can use them together to get a single product. That's the beauty of this one sign substitution. It can be, this protocol can be further extended. Why just do the abstracting the orthohydrogen to form the anilines? Okay, we can also do once we use a sodamide, and in that we add the suppose malonic ester or any reactive methylene compound, then there is a competition between the attack of the NH2 and the carbon based nucleophile, and carbon being less electronegative than nitrogen, it always attack, and you get the carbon containing this one. Then this is another example that we can even synthesize phenols. So, but we need a higher temperature there. Instead of the sodamide, we can also do, and again, you get the sign product here. So that you should not forget. Okay. Then similarly, if we have the methoxy group, okay, then again, you end up with the meta, because the methoxy group, again, oxygen has 2 lone pair. It is orthopara directing. So the meta, once the benzene form here, meta is the only position which is electron deficient. So amide species always try to form, or NH2 species, NH2 minus, form bond here. So nucleophilic attack is preferentially taking place at the meta position. Now this is tricky, that how to prepare phenol to aniline in one step. Can anyone tell me here? Phenol to aniline in one step. How will you do that? Anybody? Okay. See, there are different ways to do it, but first we should convert it into better living. So how I can convert this phenol into the better living? If I abstract its proton, phenols are acidic in nature because the phenoxide ions are sufficiently stable, because that oxygen ion can delocalize over entire ring, and it can easily attack on the chloroethyl phosphate to form O, P double bond O. So again, we use a benzene route, and we can use benzene route effectively, and we can convert the phenol to aniline. So this is the interesting, can we use a benzene route to convert phenol to aniline in one step? So this is one of the interesting example. Now 1,3-propane dithiol. Okay, it's one of the important molecule. Okay, Even if you take the 1,2-diethiol, there is also known as a Mozingo method. And in Mozingo method, we can protect, similarly, some diethiol we use, okay, 1,2-propan diethiol, and we protect the carbonyl compound, and then we deprotect it using the Rani nickel, because Rani nickel can do the desulfurization. Instead of H2, if we use a D2, we can get the 2 deuterium atoms there. So there are a lot of problems with respect to hydrogen and the deuterium in the NAT examination. Now this 1,3-propan diethiol is very important in the Omplong concept. So this sulfur is more, it's very less electronegative, so it can easily attack on the carbonyl carbon, which is electrophilic in nature. And whenever the carbonyl compound comes in contact with any acid, the electrophilicity of the carbonyl carbon increases because the electronegative oxygen bears the positive charge. So finally, you end up with the 6-membered ring. Now sulfur atomic number 16, and we know that the sulfur has the vacant orbitals, and the vacant orbitals of the 2 sulfur attached to only 1 carbon atom is sufficient for the dispersion of the charge if the carbon atom forms here. So ideally, if you have only oxygen atom, you cannot abstract this hydrogen, but if you have the 2 sulfur atom, you can do so. So if you use a very strong base like lithium diisopropylamide, you can simply form the carbon ion. The carbonyl, which was initially electrophilic in nature, now it is become electronegative or nucleophilic, and it is attacking on the electrophile, and you can attack on, suppose, dihalides. Again, you can abstract. So what is this methodology? You can prepare, once you deprotect it, you can prepare all the cyclic ketones. You can form cyclopropanone, cyclobutanone, a lot of things you can do by using the concept of the Omplong in organic chemistry. So suppose I want to use a cyclopropanone, I have to use 1,2-dichloroethane. Here I have to use 1,3-dichloro or dibromo. Okay, here 1,4 and 1,5. We can prepare all these compounds. Okay, and we can use this methodology in different place or during the total organic synthesis. So that is also the important part. This is very weird reagent that is known as a methyl-methyl thiomethyl sulfoxide. Can anybody guess what is the product here? Anybody? Can you guess? Hello? Hello, am I audible? Students?
Yes.
Yes, can you guess the product? What product will be formed with this reagent? Now see, we know we have used the concept of Omplong and we made it now reagent. So that's a reagent, something it is coming new to you. Now it is methyl thiomethyl sulfoxide. Sulfoxide means yes, double bond. Any sulfide in organic chemistry can convert to sulfoxide if you carry out its reaction with peroxide and acid. If you react it further, you may get yes, double bond O, that is sulfone. So sulfide to sulfoxide, sulfoxide to sulfone. But if we have the sulfoxide and sulfur, now these hydrogens are more acidic compared to simple Omplong, because now you have S double bond O, the charge even can delocalize. Okay. Now there is a concept of the SHAB or HSAB in inorganic chemistry, hard acid, hard base, soft acid, soft base concept. When we look for the nucleophile, so generally any nucleophile, if that nucleophile is delocalizing or its charge is dispersing, in that case it is softer. Okay, so you have to consider as a soft nucleophile, and the hard center, it should be having the very high positive charge. If I look at this typical cyclohexenone, where there is a carbon-carbon double bond and C double bond O, now this oxygen is directly in contact with this carbon. Okay, and even this C double bond O enone can delocalize. The 4th carbon is also positively charged. If I look at the strength of the positively charged of carbon 2 and carbon 4, okay, why I'm saying 2, it is carbon 1 only, but oxygen I'm counting like this 1, 2, 3, 4, because we say 1, 2 addition and 1, 4 addition. For simplicity, I'm saying this. If I say this as a 2 and this as a 4, tell me which carbon atom has more positive charge.
4.
Okay, any other answer? How many of you think the 4 carbon atom has more positive charge? See here, oxygen is directly linked with the carbon atom. Okay, so it is pulling the electron density directly through the sigma bond, but inductive effect fades when you go down, when the number of bonds increases in between. Here you can see 1 bond, 2 bond, 3 bonds. So the fading off or the effect decreases with the increase in the number of bonds in between or the intervening bonds. So obviously it has a less positive charge. So this is the hard center, this is the soft center. So hard electrophile, soft electrophile. Now if this hydrogen will be abstracted, then it is soft nucleophile or hard nucleophile?
Soft.
Soft. And where the soft will attack?
Fourth.
Fourth. So you prepare the anion of this, attack it on this position. This bond will shift here. You get O minus. Okay. Again, just like the mechanism, you can see finally you have to do the hydrolysis. So here it is double bond O and C double bond C and OH, it will form the ketone again, and this sulfur and it will break the carbon sulfur bond. Carbon sulfur bond can be easily cleaved by using the mercury ion. Okay, and it is replaced by the 2OH group. 2OH group will do the dehydration and it form the CHO. So you can directly put one CHO group here in one step, and this is the beauty of the methyl thiomethyl sulfoxide. So this is this kind of the conversion we can assess. Now here we have now 2 carbonyl compounds. One is ketone, one is aldehyde. Then the concept of chemoselectivity come, where the aldehyde is more reactive than ketone. In that case, we can protect the aldehyde, do some reaction here, and then we can deprotect. So like that, they use a complex things, many concepts at a time. So likewise, we have to understand what we should do. Then Baeyer-Villiger oxidation is very much common, and there are many examples with respect to the stereochemistry of the Baeyer-Villiger. So first of all, we should understand the per acid. Okay, now we have to, which oxygen, this oxygen or this oxygen, which oxygen does the Baeyer-Villiger oxidation? Okay, and same per acid is also used to do the epoxidation. So my question is, suppose the oxygen 1 and 2, which is electrophilic in nature? The oxygen which is attached to hydrogen is electrophilic, or oxygen which is attached to carbonyl is electrophilic? Okay, that's the question. Anybody want to respond?
Carbonyl one.
Why carbonyl 1?
And
Because it is directly attached with electronegative atoms, so electron density will pull more.
No, see, when you say the electrophilic oxygen, it is the part of the product. So there are simple tests by pen and piece of paper. We have developed that much chemistry, we can easily do it. Abhi hame kya karna hai, what we have to do? Okay, what you do now, take the per acid, make the attack of the nucleophile on this carbon atom and break the oxygen bond. In second step, make the attack on this oxygen and break the oxygen bond. You can show Nu minus and do it. Can you do it and tell me what answer you get? All of you? Can you do it? Hello? You can respond in the chat. Please do it.
ठीक है, करा मार.
Okay, anyone tried? Hello. First oxygen maybe okay. See now I tell you that how to do it, how to do this exercise. That is important. What I said that first you draw the structure and try to find out. For example, suppose I consider this oxygen and I want to prove it. So nucleophile will attack on this oxygen and oxygen bond. Okay, it will break, and what you get? You will get this species. Can you see the screen? Hello.
Yes.
I think very less number of students are responding anyway. Just a moment. Okay, can you see here? So make the attack of the nucleophile on the oxygen and this bond will break. So what you get? RCOO minus, you get the carboxylate ion. Okay, this is one. And suppose you do other way around. For example, if you attack the nucleophile on this oxygen atom, then you will get OH minus ion. Do you understand what I'm saying?
Yes,
If I do the attack of the nucleophile on this oxygen atom, you get RC double bond OO minus. This is the carboxylate ion. Okay. First, I am assuming that this oxygen is electrophilic. Now let us assume the adjacent oxygen is electrophilic. So I will attack the nucleophile on adjacent oxygen and I will get OH minus instead of RCO minus. Now we have to compare the stability of these anions which are generated, OH minus and the carboxylate ion, which is more stable, RO minus or RCO minus?
Carboxylate ion.
Yes, because this charge
RO.
can delocalize. So it means this oxygen is electrophilic, hence proved. So we can prove that which oxygen is actually electrophilic in nature, and that only take part in the mechanism. Okay, now here is one more reagent that you should understand. See, MCPBA, everyone know that metachloro per benzoic acid, everyone know. But on arrow, you may get the salt of the magnesium that is known as MMPP. It is actually a magnesium salt of, it is also called as a monoperoxyphthalate. So we know the phthalic acid. Okay, so one phthalic acid is become peroxy and one hydrogen is missing. So such two species are satisfied by divalent magnesium. So it is MMPP. It is also used for the Baeyer-Villiger oxidation. It is also used for the epoxidation. So don't get confused. If on arrow you will find the new reagent here, that is MMPP. Okay, so the migratory aptitude varies with respect to reaction to reaction. In certain cases, people also found the hydrogen has more migratory aptitude than compared to phenyl. So depends upon experimental evidences. This migratory aptitude varies. Okay, now. Okay, do you know the mechanism of Baeyer-Villiger oxidation, or should I teach you now? Simple question. Then we come back to here. Okay, by 12:30 I will start this one. Simple question. Do you know the mechanism of Baeyer-Villiger oxidation, or should I teach now? Mechanism.
Anand,
Yes.
most of the students don't know.
Okay. Now see Baeyer-Villiger oxidation. So I will share screen another one. Stop sharing. Okay. Okay, screen visible?
Oh, this stage, sir.
Okay. Now see what is Baeyer-Villiger oxidation. Baeyer-Villiger oxidation is useful in converting ketone to ester in one step. Okay. Now suppose I have a ketone. Okay. And the ketone may have its unsymmetrical ketone, for instance. Suppose we have one alkyl here and one different alkyl group. It can be one alkyl, aryl, or combination of two or same aryl. Okay. Now, if I have a situation like this and we are carrying out reaction with per acid. So what is per acid basically? It is suppose MCPBA. So it's a metachloro. So instead of metachloro, I am putting R here, and we have RCO3H. So we have R C double bond O and OH. My next question: per acid is more acidic than carboxylic acid or less acidic than carboxylic acid? Simple question. Answer is on your screen only. If you just think, see, हमें यहाँ we are not just doing under just we just don't just want to know the product. We should understand what is happening exactly. Very simple question. Per acid and carboxylic acid, which is more acidic? RCOOH is more acidic or RC double bond OOH is more acidic? You can respond in the chat box. I'm waiting. In online, nobody responds.
Acids are more acidic than per acid.
Why?
Can easily liberate the proton, but in per acid, there is no chance of easily liberation of proton
Why?
because
So
of
simple.
extra oxygen.
No, simple. What you said earlier, that only is that is the answer only. If the per acid will leave the H plus, you will get RC double bond O minus, this species, which is difficult to delocalize, which is not sufficiently stable compared to carboxylate ion. That's a simple answer. We have to look for the conjugate base. Stability of the conjugate base is important when you talk about the acidity. But anyway, it is to protonate the carbonyl oxygen. Okay, it is not like that it is not acidic at all. It is acidic so that it can protonate the carbonyl oxygen. So when it protonates the carbonyl oxygen, the electrophilicity of the carbonyl carbon increases. So you end up with, not end up, you get here OH. One lone pair is now gone. Okay, this lone pair has gone, and since oxygen has formed 3 bonds, you have now positive charge on the oxygen, and since oxygen is electronegative and it has positive charge, the electrophilicity of the carbonyl carbon is increased. So what you get now, you have now percarboxylate anion, and this percarboxylate anion acts as a nucleophile for the reaction. So you have oxygen and you have negative charge here. Okay, so this is the species what you get. Are you getting me?
Yes.
Okay, now obviously if it is a nucleophile, so nucleophile will attack on the carbonyl carbon. Sorry, it will attack on carbonyl carbon. Okay, carbon cannot be pentavalent, so bond, this charge will be diminished. Okay, the electrons will move in that direction, and what you will get now a new tetrahedral intermediate. Always remember, if we have any carbonyl compound and the nucleophile attack and you get the tetrahedral carbon, which from that you can get the different species, so that is known as a tetrahedral intermediate. So what you have now, you got R, then we have R dash. I will show it as a straight bond here. Then the charge on oxygen is now neutralized. You got OH. Then we have O. O is, this oxygen is attached to another oxygen. And this is attached to C double bond O. And here R. Do you understand this step? Hello. So the percarboxylate ion acts as the nucleophile and you get the tetrahedral intermediate, that is a TD intermediate here. Now I always say that wherever there is a possibility in organic reaction to form C double bond O, it always established. Why it established? Because of the bond energy and it is thermodynamically favored. So now when this C double bond O will try to establish here, carbon cannot be pentavalent. So one of the alkyl group, either R or R dash, get migrate to the oxygen. Now we need the electrophilic oxygen. So in the mechanism, we have already seen that what is this oxygen? This is the electrophilic oxygen that we have seen. So obviously electrophilic oxygen can take the negatively charged species. So here it's a electrophilic oxygen. Okay. Now this electrophilic oxygen can accept one of the R minus group. So suppose this is electrophilic oxygen I'm showing here. Okay, and imagine out of this R and R dash, if R dash has more migratory aptitude. Okay, so between R and R dash, more migratory aptitude means it has more tendency to donate the electron and it can move easily across the structure. So more migratory aptitude. So always remember the group with more migratory aptitude will move. Suppose we have a primary, secondary, so secondary is preferred over primary. So you should understand what is the migratory aptitude for what reaction. So if it will happen, then this R as a R minus move here, and again you get the carboxylate ion. Okay, so carboxylate ion is more stable. So जो reaction मैंने पहले बताई थी there where the OH nucleophile attack, so it's the same kind of the reaction taking place. So basic understanding is important. So what you get now, R, C double bond O and H minus departed from the system since it's acid catalyzed mechanism, because this RCOO minus takes the H plus. So carboxylic acid is a byproduct. What is the drawback or the lacuna of this protocol is, for suppose we are having 1 ton moles of per acid of MCPB, you will get 1 ton mole of same moles of carboxylic acid, and that's a byproduct. It's a huge waste. So there are certain ways where you can do the Baeyer-Villiger oxidation, where you can use hydrogen peroxide using some zeolite material, okay, incorporated with the team species or different species. So that is also the thing. So this RCO minus take this H as a H plus and you get R. What you will get, the product is RCOO, and R dash has formed bond with the electrophilic oxygen plus RCOH from the per acid, that is your byproduct. Understand this part? Hello?
Yes, sir.
Okay, now what I'll do, we go again to the screen and we will try to analyze that what product you will get. Tell me if screen is visible. Can you see the screen?
Yes, sir.
Yeah. Now see, it's a acetophenone, you can see, and per acid it will first protonate and then one of the group will migrate towards oxygen. Okay, and it will form the ester. Now methyl and the phenyl. So we know that which has more migratory aptitude, methyl or phenyl. We have already seen in the previous. So phenyl has more migratory aptitude. So oxygen will form, phenyl will migrate toward oxygen, means you have phenyl group and oxygen. So oxygen gets sandwiched between C double bond O and the phenyl ring. So that product is expected here. So in between C double bond and phenyl oxygen should come this ester, not on this side. So this is a typical migratory aptitude which is changing the product profile. That is important. Now here we have methyl group and the secondary group, that is a cyclohexyl. Which has more migratory aptitude?
Cyclohexyl.
Cyclohexyl. So oxygen should come in that direction. Now tell me, left or right? Left or right? Hello. Now see, both are benzene ring, right? But here we have a NO2. Okay, NO2 group is electron withdrawing group. So if you draw the resonating structure of NO2 group, tell me which charge delocalizes at what position. That there the answer lies. Yes. Sanket, Suman, those who are responding here, Sharayu, anybody else? See, if you draw the resonating structure of NO2, means nitrobenzene, the ortho and para position, you have the positive charge. Okay, we need a more negative charge. Okay, for migratory aptitude, we don't need a positive. Here we have positive, but here it's electronic charge. So it will migrate towards the oxygen, and that's your answer. So you should not choose another ring. Okay, because NO2 has more charge, more positive charge here. So it has a less migratory aptitude. So you may have a different substituent on the ring, and you have to choose wisely between them. Understand? Now I will go to the next one. Similarly, one very simple mechanism was given by the Bartlett. It's a mechanism proposed. It's a one-step epoxidation where carbon-carbon double bond attack on oxygen, and this kind of the mechanism takes place. And within the mechanism, you get the peroxide. Okay, so epoxide. This reaction is known as a epoxidation. Epoxidation means EP-oxy addition. EP means same side, oxy means oxygen, and addition. Okay, you cannot have epoxide two bonds, one above and one below. It cannot form the cyclic structure. We need on the same side. So if you have the cyclohexene and I want the cis diol, okay, so there is certain reagent known as osmium tetroxide. Okay, and or the if you take the simple osmium tetroxide, you can get the cis diol, or potassium permanganate can give you cis diol. This potassium permanganate solution we use in the laboratory to check the unsaturation. So the reaction is basically it is forming the diol, and it form a cyclic structure. If you look at the structure of the osmium tetroxide, OS double bond O, like that, we have to imagine it's a typical electrocyclic addition reaction, and it is forming the osmate ester, which further hydrolyze to form the cis diol. So epoxidation, again, we can use any MCPBA, that kind of the reagent. But if I need to do the syn addition of the CH2 group, then I can use a carbene. But since carbene are not stable, sufficiently stable, so we have to take use of the carbenoids. So carbenoids are generated in situ. In situ means during the reaction. So if I take the diiode of methane and add zinc copper couple, it forms ICH2ZnI, where it can give the CH2 easily, and you can get the cyclopropenated ring here on the same side. Transdiol, if I have the MCPBA and hydrolyze it in presence of acid, you can get the transal. Okay, but it becomes now two step. But if I want it in one step, then I can do the Prevost dihydroxylation, where I use the iodine in presence of the silver acetate. Okay, or as I said, you can first do the epoxidation and followed by the hydrolysis. Now there are different aspects. There are different selectivity aspect. Now if we have two carbon-carbon double bond, where the epoxidation will take place? Can anyone tell me in this structure where the epoxidation will take place? Anyone? If I look at the carbon-carbon double bond, this is a mono-substituted double bond. This is di-substituted double bond. So there are more electron donating group. So this carbon-carbon double bond is more electron rich to attack on the electrophilic oxygen of per acid. So obviously the epoxidation takes place at more substituted double bond. If I look at the double bond of the benzene ring, they are not ideal double bond because it's a part of the ring and it is involved in the aromaticity, which cannot be lost. Now, if I again look, this is again mono substituted, di substituted. So di substituted double bond is always preferred. So what is this selectivity? Two different double bonds in different regions. So it is known as a regioselectivity. Now, let's talk about another selectivity approach. Now, suppose I have a carbon-carbon double bond and epoxidation has to form, or epoxidation has to do. Now, if I have the bulkyl group on above the plane, then always the epoxidation takes place below the plane, because the per acid group along with the metachlorobenzoic acid, it get repelled by this group. So always you get the epoxide below the plane. However, if you have the OH group on some side, it may have the hydrogen bonding kind of the interaction with the per acid, then the epoxidation takes place on the same side. But if you have the oxygen containing group at the same time, the carbon structure also, then you may get the 50-50% of both the isomers. So this selectivity is known as a stereo selectivity, that how it will react above the plane or below the plane. So this is the epoxidation. You can break this double bond cis diol or the trans diol by using this reagent that is known as a sodium periodinate. Okay, so sodium periodate. So you can use a sodium periodate. Sometimes you can even use HiO4. Okay, and then you can also use a LTA, which is late tetraacetate. Late tetraacetate is not at all selective. You should know that LTA can break cis diol and trans diol, but sodium periodate can break only cis diol, because it makes the cyclic interaction. This oxygen attacks on the iodine, okay, and then in acidic medium, this OH, it forms H, it makes the H2O, it depart, and another OH also makes. So you need on the same cycle, there is a cyclic structure which is possible only in case of the cis diol, not in case of the trans diol. So sodium periodate can break only cis diol. LTA can break cis diol as well trans diol into corresponding carbonyl compound, and no trans diol does not give any product with the sodium periodate. So these are the selectivity approach when you're using this reagent for the breaking of the diols that you should know. Then I'll go to the next part. Okay, when you do, then there is one more concept known as ozonolysis. So it is typical 1,3 dipolar addition where oxygen and this carbon-carbon double bond forms a 5-membered ring, okay, which undergoes further mechanism for the breaking. So when you use just a zinc and dimethyl sulfide, which helps for breaking, you just get the aldehyde as a product. But even if you during the reaction, if you use a hydride donor like sodium borohydride or lithium aluminum hydride, you can directly end up with the alcohol, and you can also end up with the carboxylic acid if you use a peroxide during the ozonolysis process. So what is the mechanism? So it involves formation of the primary ozonoid, which gives the homolysis. Then there is also another different carbonyl oxide radical structure which undergoes dimerization, and which that tetroxane finally broke down to this compound. Okay, then there is, I will quickly go to the diol H. How many of you know about the diol? What is the specialty of the diol? Do you know the diol H? Anybody?
It is reducing agent.
It is reducing agent, but interestingly, it is a neutral. Okay, so diol is a neutral one, and this diol H, even the solvent, there is a role of the solvent. Sometimes you may do the mistake with respect to the solvent. Okay, so suppose I see the mechanism of the diol. Okay, it's a diisobutyl aluminum hydride. I am going to teach you something different. Okay, so what is the solvent effect now? We can carry out reaction in presence of the polar solvent. We can carry out reaction in presence of the non-polar solvent. But how? Okay, so let's see the mechanism. Now see, this is simple reaction. Ester is giving you aldehyde in one step, okay, in presence of the diol H. But the mechanism for both of them are different, and there may be a tricky question with respect to the mechanism. How the mechanisms can be different, the product is same. So I will just quickly show you the mechanism. What happens in the polar solvent if you use a THF? So hydride first attack on the carbonyl carbon, you get O minus, and aluminum has a vacant orbital. So oxygen form the bond with the aluminum, and you get this structure. In the next step, we have the THF already available, and THF, acts as a Lewis base, and it gives its electron into the vacant orbital of the aluminum, and then you get a typical aluminate species where aluminum got the negative charge, a typical anion is formed, and this tetrahedral intermediate can rapidly fall to aldehyde, and there is no need to do any reaction workup. Okay, and it is happening at -78°C. Contrary, when you have the non-polar solvent, again, up to this part, you can get a salt here, and you can even recover it at -78°C. Later on, what you have to do, we have to hydrolyze this salt. When you hydrolyze this salt, you get the hemiacetal. Hemiacetal means when the carbon is attached to one hydroxy and one alkoxy group, which further hydrolyze to aldehyde. So this is the difference when you are dealing with the polar and the non-polar solvent. So here we need a workup. So there may be a question that where the hemiacetal formation is favored. So hemiacetal, to get the hemiacetal during the mechanism, there must be non-polar solvent, then only it is possible. So there is, beautiful selectivity you can see. Sodium borohydride does not touch the, ester part, but it reduces only more reactive carbonyl. Lithium aluminum hydride is not selective at all. It is reducing both the carbonyl compound. But if I want to reduce only ester in presence of the carbonyl, I better, protect the carbonyl compound ketone in presence of ethylene glycol, OH, CH2, CH2OH. Then I use lithium aluminum hydride, and then I do the deprotection so that I can get the product. This is the very simple example to understand the chemoselectivity. So chemoselectivity means when we have more than one functional group and one is more reactive, and the reagent can react with both, but it will always prefer the reactive functional group. So protection concept come when I want that the less reactive functional group should react. So we go for the phenomena of the protection and deprotection. Okay, so Siemens-Smith we have already seen that how the cyclopropanation takes place, and we do the cyclopropanation. Instead of the Siemens-Smith, we can also use potassium alkoxide. Okay, and this potassium alkoxide abstracts the hydrogen, and the chlorine can be depart, and you get a typical dichlorocarbon, which is the neutral species, and you can get dichloro or dibromo cyclopropanated system when you are dealing with the Siemens-Smith, other than Siemens-Smith, different reagents. Okay, so you can, even the chloroform or the bromoform can be used as the precursor to form the carbene as an intermediate, where however this Zn and Cu is the carbenoid. Okay, and the geometry in the space, the cis bond is cis bond, it cannot be trans bond because carbon carbon double bond cannot rotate. So their geometry in the space is very well defined, and it is very easy to understand what product you will get. Okay, now epoxidation, how to do the epoxidation of the enone system. MCPB, it is very difficult to do the epoxidation. So if you use a hydrogen peroxide and use a base, then HOO minus, it is a soft because O minus is directly in contact with another electronegative oxygen. So it favored the 4 carbon atom or 1,4 addition, and then OH minus is your byproduct. So it's a catalysis, and you can do the epoxidation here. Where, however, if I want to do the cyclopropanation at alpha beta unsaturated carbonyl compound, or at the alpha beta unsaturated carbon carbon double bond, I must use a stabilized sulfurylide because it is a soft. So always remember, you can take the dimethyl sulfoxide, attack it on methyl chloride or methyl iodide, then use N-butyl lithium. You get the stabilized sulfurylide, and that can be used to do the cyclopropanation. Okay, unstabilized sulfurylides, okay, will give you the epoxide. That is very simple, all of you know. But why it is important? Because you can even synthesize the fungicides. Okay, it's a very famous molecule, flutriazole, that you can do. Okay, then there is also a needle-like nucleophile known in organic chemistry, that is known as a diazomethane. Okay, it can do the chain lengthening. Okay, so chain lengthening is possible. Now if I imagine this CH2 and this is secondary, so obviously the lengthening comes in this direction. Again, the migratory aptitude is important. And very interestingly, when you are dealing with the benzaldehyde, it is observed that the hydrogen has more migratory aptitude. So you can convert benzaldehyde to acetophenone in one step by using the diazomethane. So that's important. Now I will not go to the next part. There are some problems on the anti-periplanar relationship where you can do the semi-pinacol pinacolone. Same reagent, but the products are different. So stereochemistry and available orbital will give you a different product. Okay, I will go to now some tough problems. Okay, anybody having some problem here so far? Now I will move to the last part of today's talk. Yeah, any quick response? Is it hello? Can I get some response from you?
Yes, sir. Yes, sir.
So was Aves or those who are here, do you find the session at least little useful to you, or
More than, sir,
Yes,
Okay,
sir.
what-
Too
quite
much
useful. All we
Yes.
have learned in the third semester is get revised.
Okay, now I will go to some modern and some difficult thing. Okay, just I will just give me 2 minutes. I'm joining again. Just give me 2 minutes. Okay, am I audible?
Yes, sir.
Okay, I'm sharing screen. Okay, screen visible.
Yes, sir.
Yes,
Okay.
sir.
Now see, this is very common. Do you know what is imidazole?
Heterocyclic compound.
Yeah, this imidazole is also used as a base for the organic reaction. I will quickly draw the structure of the imidazole. Okay, typical 1,3-imidazole. Okay, where nitrogen position. Okay, this imidazole, it acts as a base for the reaction. And how many of you know TBDMSCl? Okay, it is tertiary butyl dimethyl silyl chloride. Silyl means silicon, and I say chloride. So I have one chlorine here, methyl. If you go to IIT or anywhere, many and especially in organic synthesis, you must have to use this reagent. And what I said, tertiary butyl. So this is a tertiary butyl group. So you know the tertiary butyl. Okay, so 3 methyl groups are there. So this is a tertiary butyl, methyl, tertiary butyl, dimethyl silyl chloride. This is a typical TBDMSCl. You should know what is this reagent. Now, when this is the very commonly used reagent for protection of alcohols, that you should know on the NET examination, you can see that how commonly it is used. So if the alcohol, the imidazole acts as a base, and then RO minus attack on the chlorine, and Cl minus is departed. So what you are getting here now, you are getting, what you will get, RO, then Si, 2 methyl group attached to tertiary butyl group. So we can write like this: R O T P D M S. This is the protection. You should know what is, sometimes we don't know what is that, so you should know what is the meaning of it. Understand? So this is one of the group which is used for the protection of the alcohol, that you should know. Now similarly, this is the another example what is given. Now generally when we use a LDA and THF, we use lower temperature. Reason being, at higher temperature, THF hydrogen can even get abstracted by LDA. That's why to avoid the complications, and LDA should abstract the base of only a reactant or the substrate, we avoid using higher temperature. Even at room temperature it happens. Okay, now can you predict the product here? Okay, if LDA will abstract which proton? Tell me. We'll just think on it quickly. Arey chaliye. What will happen if the LDA will be there? LDA means lithium diisopropylamide. Diisopropyl group attached to nitrogen, and nitrogen has a negative charge satisfied by lithium. Okay, it will abstract the
Methyl.
alpha hydrogen of the carbonyl. If it will abstract the alpha hydrogen of the carbonyl compound, you will get the enolate, and you will get the O minus, and this O minus can get protected further. So what I'm expecting here in the first step, what is happening? So first step, so that's why understanding of the product and the mechanism is very much important. So if this will happen, then here double bond will come, and instead of TBDMSCl, we have used Me3SiCl. So you will get O SiMe3. Understand how this protection has happened? This is happened after first step. What will happen when you use the MCPBA? What is BN? BN is a benzyl group. Okay, they are not reactive. What will happen if you use a MCPBA? So the reaction is carried out with metachloroperbenzoic acid in dichloromethane solvent, and then we use the sodium bicarbonate. Okay, so sodium bicarbonate is used to neutralize the formed carboxylic acid. So it should not do certain further complications. Okay, now if you do the MCPBA, if you use the MCPBA here, what will happen? The carbon-carbon double bond undergo epoxidation, and you get the epoxide. What is next? HCl. What happens if you do the HCl? If you use HCl here in the next step?
OSI-Me3 के ऑक्सीजन पर अटैक करेगा H.
Yes, OSI-Me3, it will get hydrolyzed. All carbon oxygen bond will get hydrolyzed. What HCl means? HCl, it is not just HCl, it's aqueous hydrochloric acid. So the water molecule will attack, it's a hydrolysis. So you will have water molecule will attack here, this bond will grow. Another water molecule will attack, this bond will move. So what you will end up with, that is important. So what is the final product? This is how in the NET exam you can see a very tricky product, but it's very easy. If the hydrolysis will take place here, okay, OSI-Me3 will go. But what happens? Since the water molecule has attacked, you will have one OH here. Okay, if this bond will break, sorry, if this bond, how this bond will break? Another water molecule attack here, so this bond will break. So you will have one OH here. And since the two hydroxyl group are present on one carbon atom, it undergoes what? Dehydration reaction. And the dehydration will give you C double bond O here. Okay, these are some recent examples from research papers. And this is how you have to prepare for the examination. And what you get, this is your final product. Typical alpha hydroxy ketone. Understand this part? This is the product. Hello, got me?
Yes,
Yes,
sir.
sir.
Okay. Now see, IBX is very common reagent. Okay, it is, you know, IBS. How many of you know IBX? First, tell me.
Don't know, sir.
I know, sir.
What is IBX? What is IBX? It is 2-iodoxybenzoic acid.
Yes.
Suppose you have iodobenzoic acid, then you can get 2-iodoxybenzoic acid, and further you can also convert it into the Des-Martin reagent. And both are known for the oxidation. You should know that they can do the iodine, they can do the oxidation. I will quickly draw the structure of IBX. Two structures of the IBX are possible. Okay, so don't get confused. Ki, "Arey, sir ne ye bataya." So I will draw both the structure. So you have iodine here, oxygen here, C double bond O. Okay, and then we have C double bond O, and we have OH. Sorry. This is the structure of IBX. Is it clear?
Yes, sir.
Okay. This is the structure of the IBX. I can draw this structure in a different way. Is, for example, suppose I may have, suppose, okay, I'm just giving color code here. I can draw O minus and I plus. Okay. So यहाँ पे if any alcohol, okay. So suppose this C double bond O, I double bond O, it attack on, okay, it is attacked by the alcohol molecule here. Okay, the very simple mechanism that is taking place. Okay, and you can, convert. Okay, I will draw this very simplest mechanism for you. Suppose you have IBX. I will draw here. Okay. And imagine this oxygen. Take the secondary alcohol, for example, RCHR OH. Means suppose you can take isopropyl alcohol, for example. Okay. And then I will quickly draw here. The nucleophilic attack can give you a system like this. We can draw the mechanism like this. Okay. And then suppose it's a secondary alcohol, you get this kind of the intermediate, and we have the hydrogen. This oxygen, C double bond O, can abstract this hydrogen. This hydrogen can give you 2 electrons here. You can get 2 double bond O here, and then finally you get the ketone. That's a very simple mechanism. You can try by your own. It's not a tricky mechanism or nothing great in that. Now tell me the product. So generally what is our understanding? Primary alcohols and secondary alcohols can be easily oxidized by using this reagent. Tell me, with this knowledge, tell me what product you expect here. Quickly.
Aldehyde and ketones.
Which aldehyde and ketone? See, here we have a tertiary alcohol and the secondary alcohol. Okay, tertiary alcohols are very difficult to oxidize. So IBX can oxidize the secondary alcohol. So the product is very simple. This secondary alcohol get oxidized to carbonyl. This is a very simple product. Can you note down this? Then I will go to the next one.
Yes, sir.
Please note down this and how to understand everything. Yeah. Okay, maybe last 10 minutes I will try to wind up. Okay, done.
Yes, sir.
Okay. Now see, there is, okay, I'm taking new screen now. Okay. Can you see blank screen?
Yeah.
Now see, there is one more known as Bestman halide. How many of you know this? Anybody?
No, don't know, sir.
No, sir.
So PH3 अभी नेट में सब ऐसा ही होने वाला है. ओके, भूल जाओ कि सब बुक से आएगा. ओके, PH3 double bond C double bond C double bond O. This halide is known as a Bestman halide. And what this Bestman halide can do? It means PH3P plus and C minus. This is your carbon which acts as a nucleophile. So what it can do? So we can have, so you can write down, you know the halide mechanism since you are MSc student. So you can write down it further, but I will tell you what miracle it can do. Suppose you have aldehydic group here, okay, and at beta position we have OH, and we carry out its reaction with the Bestman halide. The Bestman halide is capable of doing this cyclization, okay, and if we have the moiety like this, okay, you can try at your home drawing this product what I'm showing, okay, So you can have hello, am I audible?
Yes, sir.
I think I disconnected. So you understand this is new reagent. You can write down the mechanism at your home. You understand? Can you see the screen?
Yes, sir. Yes, sir.
Yes.
Yes, sir.
Okay. Now there is one more reagent. Just
Excuse
give
me, sir.
Yes.
Sir, this elide is new for us. It is, you are so kindful if you explain its mechanism.
See, it's very simple. pH3PC C minus. You make the attack. You will get the system, and you can do the response. There is a. It can this another carbon can get attacked. No, you can simply write down the mechanism. Okay, so it is not nothing great actually. Okay, so I am just explaining maximum because last 8 minutes it is nothing great. We know the mechanism of the elide, how the elide work. So phosphorus, the carbon which is attached to phosphorus acts as a nucleophile, it attack on the carbonyl, and these are the different cyclization mechanisms. Okay, so nothing great here, what I'm telling. Okay, or something new mechanism, it is nothing new or more than that. Then there is one more known as a CAN. What is CAN? Another reagent that you should know. What is CAN? Boliye quickly. We have just 7 minutes now.
Ferric ammonium nitrate.
Hello?
We don't know, sir.
Sir, yes, somebody said seric something. It is again ferric ammonium nitrate. It can be used for the oxidation. Find out how it is used for the oxidation. Propiolic acid. So this propiolic acid is, and that is used during reaction mechanism in the multi-step synthesis. It is actually C triple bond C. Hello, am I audible?
Yes, sir.
Yes, yes.
Okay, and this is the acid. This is one of the reagent, and this reagent is used to do the typical. If you have amine, you can attach this C double bond and C triple bond, this C double bond part to the amine. For example, suppose I have, I will quickly draw this NH2, and I have a 5-membered ring here, for example. Then a double bond here. Then I have, suppose, NCO2Me. Okay, now on arrow, this is from the research paper. Okay, I think CO2 yummy, it is not taking. I don't know what's the problem. NCO2 Me. I will put R maybe. Okay, this is the species. So if you carry out the reaction of this with the propiolic acid, okay, then I will just take propionic acid quickly. Now there is one more typical something new which I am going to tell you now. It is EDCHCl. Find out what is EDCHCl. Net said it is, if everything is served on your plate, you will never understand anything. What is EDCHCl? Actually, it is a typical carbidamide hydrochloride salt which is used instead of using hydrochloric acid directly as a catalyst, because to avoid the certain complications. So what you get if you use EDCHCl and the propionic acid, you will get this one, NH, C double bond O, and C triple bond C. Okay, you people don't know the mechanism of ylide? Hello?
We know the,
So-
the sulfur ylide and the phosphorus ylide.
The same way, when you take the pen and piece of paper, you can easily draw it. There is nothing great. Okay, you understand what I want to say? Triple bond will come here. Okay, right now I don't want to spend time in that. So that's the product. Okay, so there are such a there are different reagents. So that reagents you can try. Okay, there is also called as some homogeneous catalyst. Mostly there are different catalysts are there, and you can see many problems on that also. Okay, so that can be used as a reagent nowadays. Some catalyst they use. Okay, so this is how the today's NetSet examination, which is quite different than the earlier one. So I think I should stop here. You can ask me any queries if you have.
Excuse me, sir. Hello. Hello.
Hello, I'm audible.
Yes, sir. You are audible.
Okay, thank you then. Mandlik sir.
Anand.
Yes, sir.
आनंद सर मला प्रश्न विचारायचे आहे.
अरे विचारा विचारा विचारा.
सर आम्ही जे काही शिकलेलं आहे थर्ड सेमिस्टर मध्ये ते सर्व तुम्ही रिवाइज करून दाखवलं आम्हाला. फक्त
Okay.
ते न्यूमरिकल पाहिजे होते आम्हाला, तुम्ही जे स्लाइड मध्ये दाखवलेले.
न्यूमरिकल्स.
हा सर, हे जे प्रॅक्टिस एक्झाम्पल्स दाखवलेले.
ओके, हा तुम्हाला एक महत्त्वाचं सांगतो. दोज वर प्रिपेरिंग फॉर द नेट, तुम्ही कुठले पुस्तक वापरता मला सांगता का? म्हणजे व्हॉट यू आर प्रिफरिंग नाउ?
Actually, I am a student of Dr. Bapu Shingte. So
Okay.
we refer all foreign books, right?
Yep.
Like
Yes.
Jerry March, Clayton, and the other books like.
हा तर एक सी कॉम्प्लेक्स प्रॉब्लेम्स जे आहेत. ओके, देर इज बुक नॅन्स, यू नो बुक बाय नॅन्स.
Yes, I have it.
ओके, सो दॅट बुक, त्यामधले बरेच प्रॉब्लेम्स आलेत, पण आता जरुरी नाही आहे, कारण की आता लोकांना कळल्यानंतर आपली नेटची टीम वेगळी वर्क करते. सो बट इट इज अ बुक, म्हणजे जे नॅन्सचं बुक आहे दॅट इज गुड. देन रिॲक्शन कंडिशन्स, याच्यावर थोडेसे ट्रिकी प्रॉब्लेम्स. यू शुड ऑल्सो रेफर टू बारबारा कुर्टी, ते तुम्ही वापरलंच असाल कदाचित. देन देर आर ऑल्सो ब्रॅडफर्ड मुंडी, आय होप माहिती आहे तुम्हाला.
हा, येस सर.
ओके, सो मुंडीमध्ये तुम्हाला बरेच नवीन रिएजंट्स मिळतील. बट ऍट द सेम टाइम यू कॅन ऑल्सो लुक फॉर द रिसेंट पेपर्स, रिसेंट रिसर्च पेपर्स. त्यामध्ये रिव्ह्यू आर्टिकल्स असतात जे वेगवेगळ्या रिएजंट्सवर आहे. अँड देन ऑल्सो ट्राय टू गो फॉर, आय एम जस्ट रायटिंग हिअर चॅट बॉक्स. आय कॅनॉट सी चॅट बॉक्स नाउ. चॅट बॉक्स कुठे आहे? हॅलो,
खाली आहे सर हे चॅटवर, चॅट जे लिहिलेलं आहे ते.
नाही आता मला दिसत नाही. एनिवे, अच्छा, yeah. See, there is something called as a Singlet Spotlight. Okay. तर Singlet Spotlight बघा जुने. ओके. यामध्ये वेगवेगळे रिएजंट्स ऑलरेडी एक्सप्लेन केले आणि एकाच रिएजंटचे वेगवेगळे अप्लिकेशन सिलेट स्पॉटलाइट्स मध्ये तुम्हाला दिसतील. सो ते तुम्ही वाचा. त्यानंतर ऑर्गॅनिक लेटर्स मधले नवीन पेपर्स बघा, त्यातले प्रॉब्लेम्स ऍज इट इज वापरतात. जसं मी तुम्हाला आता सांगितलं की ऑर्गॅनिक लेटर्स मधले 12-13 पेपर्स टोटली न्यू. Okay, there is something called as a CBS reagent, Kore, Bakshi, Shibata. So there may be a problem on different reagents. So there is a CBS reagent. हा पण एकदा वाचा. Okay. Then there is a reagent dead. त्याचे application ज्यामध्ये आपण stereochemistry reverse करू शकतो. That is also there. Then there is also series कोरेचे बुक वाचा. सो ज्यामध्ये जिथे ऍटलिस्ट सिरीज आहे आणि ज्यामध्ये रिसर्च बेस्ड अप्रोच आहे, all the problems are coming through that for organic chemistry. So this is from my side. अवेश, आणखीन काही विचारायचं तुम्हाला?
सर ते पाठवू शकता का तुम्ही स्लाइड्स मेल आयडी वर? जर तुम्ही मेल आयडी मला द्या, नाही तर माझी मेल आयडी मी तुम्हाला देतो.
नाही, मी इथे माझा ईमेल आयडी देतो, तुम्ही मला ईमेल करू शकता. आय विल सेंड यू एव्हरीथिंग. नॉट अन इश्यू. ओके ओके, you can send me, I can share with you. Okay.
आनंद.
Yes sir.
मला वाटते आता कन्क्लूड करायचं की
आणखीन कोणाला काही प्रश्न विचारायचे आहे तर ते विचारू शकतात. आय एम जस्ट हिअर फॉर 5 minutes. माझे प्रॅक्टिकल आहे, मी जस्ट वेट करतोय. एनी क्वेश्चन? आय थिंक खूप कमी लोकांनी इंटरॅक्ट केलं, सो नॉट गुड एक्सपिरियन्स फॉर मी. आय एम एक्सपेक्टिंग की ऍटलिस्ट सर्व लोक इंटरॅक्ट करतील. सी, माझं पर्सनल ओपिनियन तुम्हाला सांगतो, डोंट ट्राय टू गेट एव्हरीथिंग फ्री ऑफ कॉस्ट. म्हणजे पैशाबद्दल नाही म्हणत आहे मी, स्पून फिडिंग. म्हणजे कोणीतरी मला एक प्लेट मध्ये वाढून द्यायचं की सर तुम्ही माझ्यासाठी रिएजंट कलेक्ट करा, मी बघतो आणि मी परीक्षा पास होतो. दॅट विल नॉट गिव्ह यू नॉलेज. ओके, तुम्ही स्वतः मेहनत करा. सरांना माहिती आहे आमच्या वेळेस सिच्युएशन, आता जेवढे तुम्हाला रिसोर्सेस अवेलेबल आहे तेवढे रिसोर्सेस नव्हते, आणि त्यावेळेस सुदैवाने 2 नेट एक्झामिनेशन होत्या ज्यामध्ये सब्जेक्टिव्ह पेपर पण होता, म्हणजे त्या मुलाला मेकॅनिझम लिहिता येत होतं. नाउ यू मे क्वालिफाय द एक्झाम बट अनेबल टू राईट द मेकॅनिझम, देन हाऊ विल यू टीच ऑन ब्लॅकबोर्ड और किंवा बोर्डवर तुम्ही कसे शिकवाल? दॅट्स अ क्वेश्चन. ओके, सिंपल मेकॅनिझम आहे. समजा इलेक्ट्रोफिलिक अरोमॅटिक सबस्टिट्यूशन, बरेच लोक इलेक्ट्रोफाईलचा बेन्झिन रिंगवर अटॅक दाखवतात. इलेक्ट्रॉन्स मूव्स, द स्पेस कॅनॉट मूव्ह, यू शुड ऑलवेज मूव्ह द इलेक्ट्रॉन टू द ऑर्बिटल. तर अशा बऱ्याच गोष्टी आहेत ज्या विथ द कोर्स ऑफ टाइम बदललेल्या आहेत. सो I conclude and I'm very much thankful to Mandlik sir, head of the department, Shivaji Science College, and all the teachers, Thakre ma'am and all other teachers from Shivaji Science College for inviting me here after a long time. It was a pleasure to me to express my views, student करता specially, आणि मी आणि पर्सनली माय ओपिनियन, आपण लोक खूप ऑर्गॅनिक करतो, दॅट इज नॉट गुड. मी पण करायचो, पण हे चांगलं नाही आहे आरोग्यासाठी, भविष्याच्या देशासाठी पण. सो राईट नाऊ आय एम मोर इंटरेस्टेड इन्क्लाइन टू इनऑर्गॅनिक अँड मटेरियल सायन्स. जसं तुम्हाला एक वेगळा गाईड मिळेल, तुमची हे बदलेल, तो डोंट बी ऍडमेंट की मला हेच वाचायचं आहे. रीड एव्हरीथिंग, लेट द टाइम डिसाइड वेअर यू मूव्ह इन फ्युचर. सो थँक्यू व्हेरी मच. थँक्यू ऑल.
Yes, sir. Please spend a few minutes for us.
Yes sir.
I welcome Rakhi Bankar madam to express the vote of thanks.
Hello, sir. So moving towards the last part of our today's session, that is the vote of thanks. A very good afternoon to one and all present here. On behalf of Chemistry Department, Shri Shivaji Science College, Amravati, I would like to express my gratitude to Dr. Anand Gurange sir for his presence and contribution for inspiring and encouraging us with and the knowledge of reagents in organic synthesis. The knowledge that you have given about the reagents in organic synthesis with wonderful presentation, it's really commendable, sir. The memoirs that you have given to the participants, it's really commendable. Different kinds of simple and complex reactions and rearrangement reactions, the mechanism of organic reactions using different intermediates as well as reagents, the smaller and minor steps that you have mentioned while solving the reactions, the wonderful interactive session with the students, and try to sort out the mechanism of different reaction using different mechanism, the stereoselective as well as regioselective as well as chemoselective reaction that you have explained. Thank you so much, sir. With the help of your guidance in today's session will definitely help the students in their preparation for CSIR NET SET examinations and also clearing the concept of respective topic. Thank you so much, sir, once again. So now with the permission of chairman, today's first session of the workshop is over and we will start our next session exactly with the new speaker, with the new topic exactly at 2 p.m. So dear participants, please join the second session exactly at 2 p.m. onwards, okay? And you should join all together and we are expecting to our participative response in a more way, okay? So thank you so much once again.
Okay, thank you, ma'am. So I'm leaving now. Thank you very much.
Thank you so much.
Thank you.
Thank
Thank you.
I request all the participants, please mute yourself because the online recording is going on. Hello, am I audible, dear students?
Yes, ma'am.
Yes, ma'am.
Now, after the lecture of the Shimpe sir, we have the feedback from the student participants. If you are interested, please convey your name on the WhatsApp group. Okay, if anyone, you can tell me now. You have just few minutes for a feedback at 5 p.m. before vote of thanks, last vote of thanks. Yes, anyone? You can convey your name to the organizer on WhatsApp group, or you can personally contact to anyone else. Okay. Yes, Shirvati is there from PVP college. He is very active yesterday. Yes. Are you there in the class? Here session. Hello. Welcome, sir.
Yes, ma'am.
Okay. Yes. Shall we start, sir?
Yeah. I don't have any problem. I'm
Okay, okay. Yes. Nice to see you, sir.
yeah.
Yes. Okay. A very good afternoon to one and all. I, Dr. Yogita Sahib Rao Thakre, Organizing Secretary of the Online Today Workshop, CSIR NET SET Examination for postgraduate students offering chemical science, organized by PG Department of Chemistry, Shri Shivaji Science College, Amravati. Once again, I welcome you all for the second session of this workshop. Dear students, your active participation is really appreciable. I hope you all inspired and are fulfilled with the knowledge from the first lecture by Dr. Anand Burangi. Today is a wonderful day, and for this session also, we have a very special guest. We pleased to welcome Dr. Bapurao B. Shinte, PhD, NET SET, GRF, Associate Professor, Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. Dr. Shinte sir has completed his Doctor of Philosophy in Chemistry from Organic Chemistry Synthesis Division, National Chemical Laboratory, and University of Pune, Pune. He has 19 years of research and 13 years of teaching experience. He was awarded as a Best Chemistry Professor of the Year 2020 Global Teaching Excellence Award, ISCB Best Teacher Award in 2018, Indian Society of Chemists and Biologists, Lucknow. He is also awarded by Bentham Ambassador 2018 and 19 and 20 and 21 by Bentham Science Publisher. Research Professor Award 2017, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. Ideal Teacher Award 2014, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. Indo-US Research Fellowship Award in 2013, IUSSTF. Shikshan Pratibha Puraskar in 2012, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. His area of research is the synthesis of bioactive compound and new synthetic methodologies. He has delivered more than 75 talks as a resource person in various national and international conferences, seminars, and symposium. He also delivered 25 lectures as a resource person in various refresher and orientation courses. Also delivered 80 guest lectures in various colleges and universities. Dr. Shinte sir chaired the session in various national and international seminars and conferences. He is BOS member in chemistry in number of universities: SRTM University, Nanded, YC Institute of Science, Satara, KBP College, Vashi, Rajeshri Shahu College, Latur, YCM Open University, Nashik, MGM University, Aurangabad. He is guest editor, associate editor, editorial board member of Mini Review in Medicinal Chemistry, Letters in Organic Chemistry, Current Green Chemistry, Current Catalysis, Organic Chemistry, Current Research, ISRN Organic Chemistry, and many more. Dr. Shinte sir is a reviewer of 45 journals, namely Nature Scientific Reports, Journal of Medicinal Chemistry, then Chinese Journal of Chemistry, Bioorganic Chemistry, and many more are there. To his credit, he has more than 110 research papers in international journal, having total citation 2,981. H-index is 31 and I-10 index is 79. He has recently published the papers in international journal having very high impact factor. Chemical Review having impact factor 60.622. European Journal of Medicinal Chemistry impact factor 6.514. And today he is with us. Let us welcome our guest, amazing and dynamic personality, Dr. Bapurao B. Shinte. He is going to deliver a talk on the topic multi-step organic transformation. He is expertise in his field, having excellent academic and research background. Now, I request Dr. Bapurao B. Shinte to guide us and share his expert opinion. Sir, please.
Very good afternoon to one and all. Thank you, Thakre madam, for nice introduction and kind words.
Thank you, sir.
It's a great pleasure and honor to me to be here as a part of resource person in the workshop organized by the Maharashtra's premier institution, that is Shivaji Shikshan Sanstha, and one of the famous colleges affiliated to that Sanstha, that is Shivaji Arts, Commerce and Science College, Amravati. From yesterday, I am listening the talks delivered by the experts in the subjects, and a special thanks to Dean Santa Gadge Baba Amravati University and Dr. Raghuvanshi sir, as well as a guest of honor for the inaugural function, our respected Professor Aswar sir. Both of them highlighted in beautiful way and encouraged a lot. Then we have heard 2 sessions yesterday, and they have delivered excellent talk, as well as early in the morning, from morning to 1 p.m. One of professor from Wilson College, he has talked about various reagents for carrying out some organic transformations. As rightly mentioned by Dr. Thakre ma'am, my topic will be multi-step organic transformations. Before going to talk on that particular topic, why the weightage is given to that particular topic. See, if you go through the curriculum or syllabus, curriculum of NET and SET. In SET, there is some specific syllabus is there, specific syllabus. But for NET examination, there is no any specific syllabus. This is the one point I want to highlight over here. If you can compare the syllabus of named reactions or reagents for SET examinations, just 10 to 15 reagents and 10 to 15 named reactions are there for SET examination. But for NET examination, there is no limit. Means named reactions or reagents or rearrangements like that way. Means there is no any specific syllabus for NET examination. Similar for GATE also. As from yesterday morning, we are talking about only NET and SET, why not GATE? That is one of the point I want to highlight over here, because yesterday a lot of deliberations was there regarding, even though after qualifying SET and NET examination, we are not getting any kind of job. Means these exams are not only for the job, but also enter in the field of research. That is the most important thing. First of all, you have to qualify either NET or SET or GATE examinations, as well as this university is conducting, that is a PhD entrance test, we are calling PET examination. Okay, this workshop may be benefited for the students. For the students, not only students, but also faculty, because if I have completed my master program 20 years before, and whatever chemistry I have learned that time, that was the old chemistry, and as per the new syllabus of UGC or a new attitude of UGC, that is choice-based credit and grading system, you have to learn many more things. And morning speaker have introduced some of the new things to you, and you should come up with those new things. That is the important thing. Okay, another aspect I want to tell you, if you want to have a NET and SET examination, if you want to qualify NET and SET examination, what is needed? That is also important. See, that's why, first of all, I will talk about what kind of roadmap one has to follow. What kind of roadmap in terms of chemical sciences? It is not a general. In terms of chemical sciences, just I have changed my plan just 5 minutes before, and please allow me to share some of the slides. 4 to 5 slides are there. Don't worry about those slides. because that slides may give idea about what I have to read, what I have to listen, and what practice I have to do for qualifying NET, SET and GATE examination. Okay, just I want to share some of these slides over here, and later on we will talk about multi-step organic transformations. Ma'am, my slides are visible?
Yes, it is clearly visible.
Yeah, just I will make it in PowerPoint presentation mode. Yeah, a roadmap to competitive examinations in chemical sciences. Okay, not only SET, NET, but also GATE. Okay, see, yes, you can look towards one of the aromatic aldehyde. You can take the example of benzaldehyde and how this benzaldehyde can be used for many named reactions. Means one starting material, one organic compound can be used for many named reactions. It starts from, you can take an example of Nobel condensation, where these aromatic aldehydes are used, Biginelli condensation, aldol, then Claisen Kimmich, then benzoin, then Tischenko, Vitti, Canizaros, Wugi, Passerni, like Hans condensation, Darzan, Dakin, Abramo, Henry, Manich, Grigdal, Beckman, Bettis. Now my question is to all of you, please put the chat box on, and whatever answer I will receive from the student community, ma'am, please give those answers to me, pass those answers to me, because I am unable to see the chat box. Yes.
Okay, sir. Okay.
My small question to the student community, can you have the name reactions which you have studied so far? Just number, in terms of number. I want to know how many name reactions you have studied so far. Just in a number, I'm not asking any names. How many name reactions you have studied so far from 11th standard to MSc second year? Because the students, those who have completed master program, definitely they have learned many more reactions. Those who are going to finish their master program, they have also studied that much number of reactions. Yes, what is the answer?
12 is given, sir.
How many?
12, 14, 15. The number of answers are there.
Yeah, there, but 12, 14, 15, it is there only. Just around 20 reactions in front of you.
14 plus 15, 17, 50.
Yeah.
Number of answers are there.
Yeah, I'm not satisfied with this answer. See.
Nearly 65.
Yeah, nearly 65 I can understand. Nearly 65 I can understand. See. If you want to crack this NET and SET examination, you have to learn around 200 to 300 name reactions. Around, I'm saying, minimum 200 to 300 name reactions. That is important thing. That's why I have raised one question. Even though you have studied those name reactions, but your preparation was like a memorization. That's why you are unable to count the number of name reactions which you have studied so far. Okay. Before going to start my lecture, always I have to salute these peoples. Their contribution, we have to salute to them, because just we are reading their chemistry, and we are understanding whatever chemistry these peoples have done in the last century. Okay. Now my next question to all the students, not only students, but also those who are participated in this particular workshop. Who is the first person over here? What is the name of this person? First one. What is the answer? Yeah, chat box is there. You can write in chat box. What is the name of that first person? If you are going to prepare for NET, SET and GATE examination, and if you want to become a master in organic chemistry, you have to know the grandfathers of organic chemistry. Yeah, any name, ma'am? Hello?
No, sir.
No. Yeah, I'm worried about the students, because if they don't know the name of this person, then how they will prepare for NET, SET and GATE examination? Because whatever chemistry we are studying made by these peoples. See, okay, without wasting time, I want to tell you the first person is a great Nobel laureate, and he has introduced the term of synthesis, total synthesis, and he has done total synthesis of cholesterol in the year of 1928, which is of 57 steps. And at that time there was no spectroscopic facility, only only degradation method was there. No single crystal X-ray. Then also they have deduced the structure of cholesterol along with 8 chiral centers. And see, we are studying cholesterol, but we don't know who has synthesized the very first time. And he is the great Nobel laureate, that is Robert Woodward. Even though we are studying so many rules given by him. The next person, do you know the name of this person? Okay. See, this is a great Nobel laureate, Elias James Corey, E.J. Corey. Just morning, Dr. Anand sir has discussed about one of the reagent, that is Amporan concept, that is 1,3-diethine, and he is the man who has discovered that particular concept. He is nothing but E.J. Corey, and he has introduced the first time the concept of retrosynthetic analysis, and he has derived so many natural products, and more than 100 people from the India, they have completed their PhD as well as a postdoc program under his supervision. Till date, at the age of 94, 95, he is still working in the laboratory. Okay, then next person, we are studying his chemistry, that is the Sharpless asymmetric epoxidation reaction, Sharpless asymmetric dihydroxylation, amino hydroxylation reaction, and he is a great Nobel laureate, received a Nobel Prize for his contribution to the asymmetric oxidation reaction. Please mute, somebody has unmuted. Please mute yourself. Okay, then the fourth person, he is nothing but a great Nobel laureate. Again, he has derived or made carbon-carbon double bond with the help of phosphorus halide. He is nothing but George Whitty. Then he is a George Wola, who has received a Nobel Prize for the contribution towards the generation of carbocation and utility of the carbocation. Just recently, he has passed away at the age of 101 years. Then the last person, everyone knows, we are studying his chemistry from 11th standard to till date. He is nothing but Victor Grignard. That is the preparation of RMGX. Okay, not only these persons, but also there are some other peoples, and just we are reading their chemistry. He's a Grubbs metathesis, that is carbon-carbon double bond formation. Okay, and in the year of 2007, he has first time visited to India, and especially to NCL Pune, and later on he has visited our university also. Okay, then the three persons, Suzuki, Heck, and Negeshi, for their contribution in carbon-carbon bond formation, they have received a Nobel Prize in the year of 2010. Then this person, B.M. Prost, he has received many more awards for his contribution in organopalladium chemistry. And this person, we are reading his books, that is Francis A. Carey, Organic Chemistry by Francis A. Carey. He is a great teacher, great researcher. Then his books, this person, his books we are reading, that is molecules that changed the world, as well as classics in total synthesis. He has written 3 volumes of those books, and these books are excellent books for understanding of organic chemistry. And if you want to excel in NET examination, then you have to read such kind of books. Definitely the last person who belongs to India, and he is a great Indian organic chemist. He is nothing but Gordon Mehta, and salute to these people first, and then I will start my lectures. Now, how to learn organic chemistry, how to become a master in organic chemistry, that is important. And in the morning session, Dr. Anand have asked which books you are referring. See, books makes an impact on the preparation of your master's program, your competitive examinations program as well. If you are reading quality books, then you will understand quality subject. That is important. If you are reading from textbook or small books, or the books which are having so many mistakes, then your knowledge will be like mistake. Your knowledge should be mistake free. That's why the first point I used to consider in becoming master in organic chemistry, you have to read quality books. You have to read quality books like Claydon, Carey, then Jerry March, M.B. Smith's books, Advanced Organic Chemistry by Jerry March, this Peter Sykes. No doubt, some of the books are difficult to understand, but if you read many times, definitely you will get understanding of these books. Not only these books for understanding reaction mechanism, but also there are some special books and which I have to consider. These books are for me. These books, I'm referring such kind of books for the preparation of master's program, for the preparation of competitive examinations, definitely I will succeed in those examinations. See, these two books, this is the third edition, this is the second edition, written by the M.B. Smith, Organic Synthesis by M.B. Smith, which is the Bhagavad Gita, Bible and Quran of organic chemistry. Then the book Carothers book, it is an excellent book for carbon-carbon bond formation reaction or oxidation reduction, or you can cover most of the organic chemistry from these two books. And as well as in the morning session, Dr. Anand have told about this book, Nan's books. This is the first edition and this is the second edition, which is now available in India, second edition. In earlier days, the first edition, which was in only Jaikar Library of Pune, and the very second book with me, original book. Okay, then if you want to prepare some named reactions from the quality books I am saying, not from Gurdeep Raj or Sanyal and Sanyal, Verma, Sharma, Jagdamba Singh. If you are referring such kind of books, then you will not succeed in competitive examination. This is my suggestion to all of you. If you want to prepare named reactions, 300, 400, 500 named reactions, then you have to read quality books like the books written by Mundi, Gijakli. See, Mundi, name reagents and reactions in organic synthesis by Mundi, name reactions by Gijakli. And if you want to learn many more name reactions related to heterocyclic synthesis, that is name reactions of heterocyclic chemistry 1 and 2 by Gijakli, as well as this name reactions for functional group interconvergence. Functional group interconvergence, again, very good book of organic chemistry written by Gijakli. Gijakli is a student of E.J. Kore. See, and then early morning, Dr. Anand is talking about another book written by Barbara and Kurti, that is the strategic applications of name reactions. And see, the cost of these books are not too much. Some of the books are cheaper, but some of the books, they have a very high cost. No doubt, this book written by Barbara and Kurti, the cost is around 2,000 rupees. And then if you want to learn real organic chemistry, then you have to learn retrosynthetic analysis. And to learn retrosynthetic analysis, you have to read The Logic of Chemical Synthesis by E.J. Kore or Organic Synthesis Disconnection Approach by Stuart Warren. Just recently, he has passed away, Stuart Warren. Okay, not only these books, but if you have a library of reagents for organic synthesis written by Fischer and Fischer, total 22 volumes are there. Even though it is a difficult when you are in MSc master's program, it is a difficult to read such kind of volumes. But after completion of your master program, you have to read such type of books. Then only you will become master in reagents, master in organic chemistry. And this is my first suggestion to all of you. If you want to become a master in organic chemistry, you have to read quality books. Okay, quality books. Then, second point, I used to consider for becoming master in organic chemistry that you have to listen the lectures delivered by the experts in the subject. Experts in the subjects. I am not expert for all the topics of organic chemistry, but I am expert in some of the topics. I am expert in some of the topics, like just you are doing the job of listening. You have to listen the lectures delivered by the experts in the subjects. Experts in the subjects. Okay, this is the second point. And the third point, after reading the quality books, after listening the lectures delivered by the experts in the subjects, you have to prepare the notes by yourself. That is important thing. You have to prepare the notes by yourself. Not if somebody have prepared the notes and just you are taking the xerox of that notes, that is not useful for the preparation of this competitive examination like NET, SET and GATE examination. That's why prepare a note, preparing the notes by yourself. Whatever things you understand, just put on the notebook, put on the paper, make notes by yourself. That is the third suggestion to all of you. And fourth one, as we are doing a lot of experiments in the laboratory. From last 1.5 years, it was not possible in the lab, but whatever things we have performed so far, those experiments we have to do with understanding. Otherwise, some teacher is providing some procedure to you, and accordingly we are doing that practical just by weighing and just adding some of the reagents. Why I'm adding those reagents, we can't understand. That's why with understanding you have to do those experiments. Means four points I have discussed so far. One is reading of quality books. Second one is the listening of the lectures delivered by the experts. Third one, preparing notes. And fourth one is you have to do experiments in the laboratory with understanding. This is the third point. And just I want to focus another points. If you want to become a master in organic chemistry, there is a need of some study partners. Okay, study partner group discussion is important because see, you will be surprised at what you learn when you have to explain something to others. If I understand the book of Carothers and I am sharing those understanding with my colleagues, with my friends, then definitely I will not forget that book forever. That's why don't consider I will prepare myself. No, after understanding that concept, you have to discuss with others and you will not forget forever. Okay, that's why getting together to do work with your colleagues is a fantastic idea. That's why coming together is a beginning, keeping together is a progress, and working together is a success. This is the mantra of qualifying SET, NET and GATE examination. That's why see the students from our university, they are qualifying in huge number. This is the mantra they are following. Coming together is a beginning, keeping together is a progress, and working together is a success. This mantra is given by Henry Ford, and that's why see, even though you have read some of the books, you have listened the lectures delivered by the experts, you have prepared the notes. But the most important thing, after understanding of any topic from the organic chemistry or inorganic or physical chemistry, whatever exercise is given at the end of each and every chapter, you have to solve those exercises. That's why it means that you have to solve the problems, number of problems. That's why learning organic chemistry requires problem practice, and you should attempt questions from reference books. See, this is the most important point. You should attempt questions from reference books and hit the past question papers. Spend all the extra time you save from theory for organic chemistry into solving problems. That's why work the problems. That's why there is a one quotation: grindstone sharpens knives, problem solving sharpens minds. Grindstone sharpens knives, problem solving sharpens minds. Just quickly, we will have some of the problems and then we will talk about what kind of problems. See, again, how to become master in organic chemistry quickly. You should have a n number of named reactions and rearrangement. You should know about 500 named reactions. Around, I can take in one stroke 1000 named reactions. 1000 named reactions in one stroke without taking any kind of gap as well. What is that reaction? What is the function of that reaction? And what is the utility of that reaction? That is important. You should know about n number of named reactions, because in NET examination, there is no any limit for named reactions as well as the rearrangements. As in the morning session, Dr. Anand has focused on some of the reagents. I'm saying some of the reagents, just oxidizing agents, some of the oxidizing reagents he has focused on. But if you want to learn the reagents, you have to read the quality books like Carothers, M.B. Smith's books, then Nan's books, then Claydon book, as well as finally, at least your mentor, your professor has to read the books written by Fischer and Fischer, that is reagents in organic synthesis. That's why reagents are important in qualifying NET, SET and GATE examination. Then, as we know different types of reactions, as well as, see, nowadays, for every organic transformation, they are asking about the stereochemical aspects of that particular reaction. Means you should know about the stereochemistry, asymmetric synthesis. This stereochemistry you have to prepare from Eli book, not from other books. Eli book, asymmetric synthesis, asymmetric catalysis, you should know. Then most important thing is protective groups, that is protection and deprotection chemistry. Morning, one of the transformation he has covered, that is protection of alcohols by means of silyl ethers, that is TBDMS ether. See, the focus on protection and deprotection, because protection and deprotection around 8 marks or around 4 to 6 marks are coming on protection and deprotection chemistry. And finally, organic chemistry is nothing but functional group interconvergence or functional group transformations, special focus on oxidation and reduction. In oxidation, so many oxidizing agents are there, so many reducing agents are there, metal-based and non-metal-based oxidizing as well as reducing agents. Okay, with this, just we can have quickly some of the questions. Suppose now chat box can be there. How many constitutional isomers exist for C6H12 that have a cyclopropyl ring in their structure? Why I have considered this question? If such type of question is asked in the university examination, just we are giving suppose 1 answer, 2 answer, 3 answer, 4 answer, 5 answer, 6 answer, like that way. Then accordingly, we the teachers are giving marks to the students. But in NET examination, they are providing NET or SET or GATE examination, they are providing answers to you. But here I used to ask, what could be those structures? Okay, what could be those structures? See, how many constitutional isomers exist for C6H12 that have a cyclopropyl ring in their structure? And this question, I think more than 100 times I have asked, but till date, only 1 or 2% they have given correct answer of this question. But later on, if I ask the further question, what are those structures? Then students are unable to give answer of this question. Not only students, but also teachers, those who are SET, NET and GATE qualified, as well as a PhD. Okay, now without wasting the time, because I have to do lot of work over here, multi-step organic transformation, just I am introducing such kind of topics. See, there are total 6 structures, and in each structure, cyclopropane ring is there and having molecular formula C6H12. In first structure, 3 methyl groups on the 3 different carbons. Here, 2 methyl groups on the same carbon. Here ethyl group, methyl group, here isopropyl group, here N-propyl group, here ethyl and methyl group. See, all these 6 isomers, 6 structural isomers are there. Now, this second question, if I ask this one, okay, how many alkenes having molecular formula C7H12 could you treat with hydrogen platinum to prepare methyl cyclohexane? Yes, what is your answer? How many? Give in numbers. Can you have an answer of this question? Yeah, students. What is your answer? Be alert, be active, because this is the question of 12th standard. How many alkenes having molecular formula C7H12 could you treat with hydrogen platinum, just hydrogenation reaction, to prepare methyl cyclohexane? Am I audible? Hello?
Yes, you are audible, sir.
Yes, sir.
Yes, sir.
Yeah, but students are totally inactive.
100. Yes, and what we are giving the student give answer. Yes, please, student, give the
Yeah,
answer.
how many alkenes that will form methyl cyclohexane having molecular formula C7H12? If you are going to prepare for NET and SET examination, you should be alert.
Try to find out the answer.
Yes,
What is
somebody
given?
have given answer 1. Somebody have given answer 1. Yeah. Some Sanket Shirsat has given answer 1, which is wrong. Which is wrong.
Only one. Amruta Mule.
Yeah. Again, it is wrong. Though. Yeah, this is the question of 12th standard, not of MSc. 12th standard. Yeah, somebody have given the answer.
4, 5.
Yeah, somebody have given answer 4. Somebody have given answer 5. Yeah, Mali Nikita have given answer 4. Nita Rasal has given answer 4. Okay, now see here. I will tell you. But if I ask this structure, then the question may be difficult. And same type of questions we are asking to our students in university examinations. Draw the structures of the alkenes having molecular formula C7H12. Could you treat with H2PT to prepare methyl cyclohexane? Okay, see, not only the number of alkenes, but also we are asking the structures of those alkenes. And if you give correct answer, then you will get 100% mark. And if you are giving wrong answer, then you will lose not only 4 marks, but you will lose 5 marks in net examination. See, the molecular formula is a C7. Could you treat with hydrogen platinum to prepare methyl cyclohexane? What is needed over here? You should know the structure of methyl cyclohexane. Okay, and accordingly, you can have the structure of the products over here. See, this alkene, methylene cyclohexane, methyl cyclohexane, this methyl cyclohexane, and this methyl cyclohexane. See, in this case, reduction of this double bond leads to methyl cyclohexane, reduction of this double bond, reduction of this double bond, as well as the reduction of this double bond, which leads to methyl cyclohexane. That is the answer, correct answer of this particular question. Okay, now the next one, just I will skip this one. Yeah. Okay, I will skip this one. Yeah, first question. When phenol is reacted with chloroform and NaOH, the product formed is. What could be the product? Do you have any answer? Put in chat box for first question. Be alert. What is your answer? Either A, B, C, or D. Quickly. Yeah. Most of the people, they are writing B. Okay. Why B? Just I will explain in short. Because see, phenol is reacted with chloroform and NaOH, means Riemann-Tiemann reaction and formation of salicylaldehyde takes place, not salicylic acid, benzaldehyde, or benzoic acid. Now next question is for you. When phenyl magnesium bromide reacts with tertiary butanol, which of the following is formed? What is your answer? Read quickly. Because you have only 1 minute to solve this particular question. I will tell you answer, definitely.
Again, B is the answer. B is the answer given by the participants.
Okay. Yeah, good. If you are giving answer B, then it is correct. Otherwise, see, just listen the words. Any Grignard reagent on reaction with any alcohol, that Grignard reagent will abstract the proton only. And formation of corresponding hydrocarbon. If you have phenyl magnesium bromide and methanol or ethanol or tertiary butanol, that pH minus will take the proton and formation of benzene. Most of the time, students are unable to give answer of this question. They are saying that tertiary butyl methyl ether, tertiary butyl benzene, or phenol. But that is the wrong answer over here. Okay, then. Okay, everyone knows Lucas reagent. I will skip this one. Just now we have seen. Yeah. Now, see this question. The most suitable reagent for the conversion of RCH2OH to RCHO. What kind of reagent you can have? Can you write in chat box? Just I am taking over half an hour. I can spend on this particular transformation because I should know what students should know first. Yes. What kind of reagent? Somebody have given the answer.
Answer D is given.
No, I have not given any kind of option over here. The next question, the most suitable reagent for the conversion, RCH2OH to RCHO. Somebody have read PCC. Yeah, good. PCC. PCC is the right answer. Why PCC? Please set your camera not visible properly. Okay.
Yes, sir. We want to take the photos. That's why I write.
Yeah. I can take in the center because yeah. See, yes. Yeah, because I can see my full screen. That's why I have kept my camera aside. See, here I can provide you the reaction conditions.
We want geotag photos for that.
Chromium trioxide, PCC, and KMNO4. See here. Why K2Cr2O7 and KMnO4 is not there? Because these are the two strong oxidizing agents which converts primary alcohol to carboxylic acid. That's why these two reagents are not suitable reagent. As well as chromium trioxide, over oxidation may takes place. That's why pyridinium chlorochromate, one of the reagent, write in your notebook, that is chromium based oxidizing agent, that is PCC, PFC, PDC. Okay, Collins reagent. Okay, then Sarret reagent. Like that way you have to prepare for understanding of oxidation reaction. Okay, then quickly another question, just I can take simple question. Yeah, okay, yeah. Read this question. In which of the following reactions new carbon-carbon bond is not formed? You have 1 minute. You have 1 minute. Can you try to solve this question in 1 minute? Just quickly, what is your answer? Yeah.
A is given, C is given, someone. Yes, A is given by the maximum number of the students.
Oh, they are good. They are good if they are giving A, because see, if they have understand question properly, only those people have given correct answer. That's why I have read the question. New carbon-carbon bond is not formed. In Friedel-Crafts reaction, carbon-carbon bond is there. In Arnold condensation, carbon-carbon bond is there. In Woods reaction, two alkyl halides on reaction with sodium metal, formation of higher hydrocarbon. But in Cannizzaro reaction, one of the aldehyde gets oxidized and another aldehyde gets reduced. That's why the answer is Cannizzaro reaction. Okay, then. Okay, just I will skip this IUPAC nomenclature system. Yeah. Quickly. Yeah, now again you have only 1 minute to solve this particular transformation, the appropriate reagent for the transformation. Can you have the answer for this question? Quickly.
Option A, option D.
Yeah, we have to wait for a minute.
D.
Yeah, maximum people they are saying option D, option D, option D. Okay. Why they are saying D? That I don't know. Why they are saying D? Means they have not studied reagents properly. That is the most important point over here. See, most of the people they are giving answer D. See, I will tell you from D I will come. See, this D is nothing but sodium borohydride. Sodium borohydride, it reduces carbonyl group to alcohol only. Carbonyl group to alcohol, not carbonyl group to methylene group. Then hydrogen nickel also reduces carbonyl to alcohol, not methylene group. Then ZnHgScl, that is Clemmensen reduction. Reduction of this ketone to hydrocarbon takes place, no doubt, as well as elimination type of reaction takes place over here. Dehydration, because the condition is acidic condition. Now, B, that is a Wolff-Kishner reduction by using hydrogen hydrate, hydrogen and potassium hydroxide in ethylene glycol. Reduction of this carbonyl group to hydrocarbon takes place, along with this OH group remain intact. Means basic medium is required, not acidic medium. Okay. Then another question quickly. Yeah. See this question. What halide is needed to make 3-ethyl 3-heptene from 3-pentanone in Wittig reaction? If such type of question is asked in your university examination, okay, and if the examination is a descriptive, then to solve this particular question requires you have to know the starting material, that is a 3-pentanone, structure of 3-pentanone, as well as structure of your product. Then only you can find out what kind of phosphorus halide is needed over there for carrying out this Wittig reaction. First of all, you should know what do you mean by Wittig reaction. Okay, what do you mean by Wittig reaction? What kind of phosphorus halide is required to make that particular alkene? See over here. Yeah, what is your answer? Can you tell me the answer? What is your answer? Can you write in chat box?
D is given, C is given, someone B is given, everything is given. C is given mostly.
Yeah. Those who are giving C answer means they are preparing, really they are preparing for NET examination. Really they are preparing for NET examination because see, simple job is there. In 3-ethyl 3-heptene, how many carbons are there? Heptene means 7 carbons and 3-ethyl group is there. 7 plus 3, 10 carbons. Here 3-pentanone means 5 carbons are there. Okay. Here see 3-heptene, 3-ethyl. 3-ethyl 3-heptene. And starting from 3-pentanone. Pentanone, 5 carbons are there. See the number of carbons in your starting material and in the product, that should be the match. Okay, and see, there is a need of drawing the structure of 3-pentanone first. Like 3-pentanone, definitely I will take this question in our whiteboard later on also. But those who are giving answer of this question, see, they are correct one. Okay, definitely I will take in whiteboard. Then I will skip this question and this final last simple question I will take over here. Yeah. Which of the following aldehyde is required to make the compound? To make this particular compound. What is your answer? What is your answer? See, for this question, again, quickly, I am considering you have a sound background of organic chemistry. Sound background. Because this is the organic chemistry of 12th standard only. Yes.
A is given, sir.
Okay, we have to wait. Somebody has given B.
B also given.
Yeah, B, again B. I will tell you. How to explain without using any kind of board. Yeah, B, D. See, 2-phenyl-butanol. 2-phenyl-butanol means this aldehyde at 2 position, this phenyl 3-4 means there should not be any kind of phenyl ring. And how that aldehyde can be used to make this particular compound, it is not possible. Then benzaldehyde. Benzaldehyde is also not suitable starting material for preparation of this particular compound. Then 2-phenyl-propanol means this aldehyde phenyl group and here CH3 group. How we can make carbon-carbon double bond over here. And finally, this phenylethanol means phenylacetaldehyde. If you can take this one pH CH to CHO, 2 equivalents of pH CH to CHO, aldol condensation reaction, you will get this kind of product over here. Okay, that's why A answer is correct. Okay, now we can have this particular question. What 2 components can be used to prepare a following compound using the Robinson annulation reaction? Okay, answers are there. Okay, it is not like a university examination. NET, SET and GATE examination, they are very much easier as compared to university examination because each and everything is there. Just you have to find out correct answer. Correct answer. Then only you will get 100% marks. Yes, see, if you want to see this question, if you want to answer the question for this question, Robinson annulation, you have to know. What is Robinson annulation? First of all, you should know Michael addition reaction followed by intramolecular aldol condensation reaction. Michael addition followed by intramolecular aldol condensation reaction. Those who have studied retrosynthetic analysis, they are able to find out respective starting materials very easily. Because see how to analyze the starting material with the help of retrosynthetic analysis. Just you can do this alpha beta unsaturated double bond, carbon-carbon bond breaking reaction here, CC double bond, here carbonyl group and CH3 group is there. Means here CH2, CH2, CO, CH3 and this 1,5 difunctionalized compounds you can break from 2,3 bond, you will get directly this particular answer. Okay, C answer those people have given, they are correct, but we have to focus on the wrong answers also. If you have this A option, alpha beta unsaturated ketone, cyclopentanone is there, and if you carry out reaction with this active methylene group, Michael addition reaction takes place and followed by cyclization, never gives such type of product. Here also same type of active methylene compound, Michael addition reaction over here and followed by you will not get such kind of products over here. Here also Michael addition reaction is possible, but intramolecular aldol condensation which never gives this particular methyl group and cyclic product over here. That's why first Michael addition on this carbon and then intramolecular aldol condensation reaction takes place. That's why C answer is the correct answer over here. Okay. Okay. Just I will skip this part and I will share another presentation. Okay. Just a minute. Yeah, meantime, if you have any kind of queries, doubts, you can ask me. Because just I will share my whiteboard and we will have a practice of solving multi-step organic transformations. Just share whiteboard. Zoom वरती तर याला. Sorry, just 1 minute. I am sharing my presentation.
Basic whiteboard.
मॅडम व्हाईट बोर्ड शेअर होत नाही माझ्याकडनं. ठाकरे मॅडम,
Yes, sir.
जस्ट व्हाईट बोर्ड शेअर होत नाही, काहीतरी प्रॉब्लेम मला कळत नाही, लक्षात येत नाही. जस्ट
Okay.
एक हा
ठीक आहे सर. You take your time.
यस.
Okay, sir. Okay.
कारण झूम वरती शेअर होतो, पण आता माहित नाही का होत नाही याच्यावरती, मला कळत नाही.
नाही होईल ना सर. स्क्रीन शेअर होते सर झूम वरती.
शेअर
ओपन करून आपल्याला मिनिमाइज करावी लागेल, तेव्हा शेअर होईल ती.
वॅककॉम दिसत नाही काही तर. एक मिनिट. इथं सर्च कसं करायचं रे? नाही, मला वॅककॉम डेस्कटॉपवर.
डेस्कटॉपवर का?
हा, एक मिनिट.
सर आता करून बघा होतं का? हॅलो हॅलो.
हा, बघतोय मॅडम, बघतोय.
कारण तुम्ही इंटरनेट कनेक्शन बहुतेक गेलं होतं होस्टचं, तुम्ही कोहोस्ट निघून गेले होता. आता पुन्हा कोहोस्ट केलाय तुम्हाला, आता होईल स्क्रीन शेअरिंग.
बर बर बर.
हा, त्याच्यामुळे तो प्रॉब्लेम होता. येस. हा, दिसलं सर तुमचं स्क्रीन आता.
एक मिनिट.
हा, येस.
वॅककॉम येत होतं की रे? तिथंच बसणार. वॅककॉम आपण सर्च करत आहे. परत एकदा करू का? तिथं टाकायलाच येणार सर्च. का सगळंच कट कर?
क्लिक करत वरच होईल ना.
एक मिनिट. कंट्रोल येत मला. डेस्कटॉप सेंटर.
कसं ओपन करायचं?
मग डायरेक्ट सपोर्ट. हा, योग्य इथं आहे. हा, आता ह्याला मिनिमाइज करू का?
हा.
नाही, व्हाईट बोर्ड
ती ओपन करायची.
Yes, sir, it is visible now.
Yeah, but it is not coming. Whiteboard is not coming, ma'am. There may be some kind of problem. I don't know.
The screen is visible to us.
Just wait a minute.
Yes.
Support.
sir.
इतना ही माहिती तुम्हाला.
हेलो सर.
हाँ, yes.
सर नया अपडेट आया हुआ है, वो नया अपडेट कर लीजिए सर. आपका वेकॉम में अपडेट नहीं है सर आपका सॉफ्टवेयर.
अभी तो नहीं, अभी तो टाइम लगेगा ना अपडेट करने के लिए.
हो जाएगा सर 2 मिनट में.
नहीं होता है टाइम.
तुम्ही धोती नाही घालत? नाही मी धोती घालत.
Welcome tablet properties audio.
हेलो सर.
हाँ बोलो.
सर पावर पॉइंट प्रेजेंटेशन पे ब्लैंक स्लाइड्स लेकर आप उस पे चला सकते सर.
चला सकते हो उस पे.
व्हाइट बोर्ड दिया सर.
ओके ठीक है. मालूम नहीं, आज फर्स्ट टाइम सच डिफिकल्टी. फर्स्ट टाइम ये आ गई, आज अभी आ गई. सुबह मॉर्निंग में लेक्चर लिया है मैंने. ओके ठीक है. मैं तो ऐसे ही पावर पॉइंट प्रेजेंटेशन करूंगा, कोई प्रॉब्लम नहीं है. आई हैव दैट पावर पॉइंट प्रेजेंटेशन. ओके जस्ट या जब वक्त होता है.
असं डायरेक्टली स्टोर होणार पाहिजे सर. असं बोलणार. काय प्रॉब्लेम नाही.
अपडेट इज नीडेड.
नीड आहे.
तेच शेअर व्हायला फक्त. हे असं शेअर म्हणून का
ड्राइव अपडेट.
अपडेट म्हणू का? शेअर करू.
शेअर आहे.
व्हाइट बोर्ड म्हणून तर डायरेक्ट व्हाइट बोर्ड हे शेअर करे. हे करून करायचं.
एक्स्ट्रॅक्टिंग.
चल पावर पॉइंट प्रेजेंटेशन. Yeah, am I audible?
Yes sir.
Yeah. Lot of problems are there in
Yes,
using this whiteboard. I don't know what is the reason. First time from last 1 year I am facing this problem. I don't know, but I could manage through this on through PowerPoint presentation because I have PowerPoint. But I doesn't like such type of PowerPoint presentation for organic chemistry. Okay, I used to teach organic chemistry through whiteboard itself, and just we will talk about remaining problems. So please excuse me for that one, that disturbances. Okay, just orally I will tell you because it's difficult to tell the mechanism of such type of reactions orally. It is not possible. Okay, but accordingly we can solve such type of problems. Yeah, in future, if I get an opportunity, once again, definitely I will talk with the students of Shivaji College, Amravati, no issue. Can I share my presentation?
Yes, sir.
Yeah, okay. Huh? Just a minute. कुठे आहेत परीक्षे? कसं stop sharing, huh? Yeah. Whether slide is visible? Hello, Thackeray madam.
Yes, sir.
Yeah.
Yes, sir.
Yeah. Now orally we can solve such type of problems and how to give correct answer. How to give correct answer if such type of problem is asked in the NET or SAT examination, NET or GATE examination for 4 marks. See, this is the problem. The correct sequence of the reagents to be employed in the following transformation is. See, there is some alpha beta unsaturated ketone and in the product ketone group is there and a double bond, and that double bond is having configuration that is a Z configuration is there. While solving such type of problems, if you know one step, then and if you don't know remaining steps, then you are unable to give answer of that particular question. But definitely I will discuss how to solve such type of problems if you know only one step as well. What kind of tricks one has to follow in solving such type of problems? See, first of all, look at towards the starting material as well as the product. How many carbons are there in the starting material and how many carbons in this product as well? Is there any difference between starting material and product? Okay, see over here. In starting material, towards this side 1, 2, 3 carbons are there, and towards this side 1, 2, 3 carbons are there. Okay, here towards this side 1, 2, 3 carbon. Okay, 3 carbons are there. Means either this carbon gets converted into ketone group or this carbonyl group remains as it is. This is the one thing. Second thing, there is a double bond. And towards this side 1, 2, 3, 4, 5, 6, 7, 8 carbons are there. And if I consider 1, 2, 3, 4, 5, 6, 7, 8. These are the number of carbons maybe towards this side. Okay. Now another thing one has to know about the formation of Z olefins. How Z alkenes can be formed? Z alkenes can be formed by the reduction of alkynes. By the reduction of alkynes, then for the reduction of alkynes, 2 methods one can use. One is a Birch reduction and another one is by using Lindlar catalyst. For Birch reduction, we will get a trans product, that is E product formation takes place. And under Lindlar catalyst condition, you will get Z product. Okay, we know these things only. Okay, now see over here, 2 options are there. Hydrogen, palladium on barium sulfate, hydrogen, Lindlar catalyst is there. These 2 are same. Palladium on barium sulfate is the Lindlar catalyst. Means we can remove these 2 options quickly. Now we have 2 options, first and last. First and last. Okay, now see over here. Now see the transformation, this carbon is converted into ketone group and this carbon gets converted into double bond. Means there is a one named reaction. And while going through the syllabus of UI University, that is Sant Gadge Baba Amravati University or the other universities of the Maharashtra, they don't have this particular reaction in their curriculum. And this example, not only this example, but similar type of example have been asked in a NET examination for 4 marks 3 to 4 times in the last 5 to 6 years. And this is one of the best named reaction, that is Isham-Moser-Tanabe fragmentation reaction. Okay, Isham-Moser-Tanabe fragmentation reaction, that is important reaction. That is conversion of alpha epoxy ketones to, listen carefully, alpha epoxy ketones to keto-alkyne formation takes place. Alpha epoxy ketones to keto-alkyne formation takes place. And to make alpha epoxy ketone, it requires alpha beta unsaturated ketone first. And here we have alpha beta unsaturated ketone. And how to make alpha epoxy ketone from this alpha beta unsaturated ketone? There are two reagents, that is MCPBA and H2O2. Because these two conditions are applicable only 1 and 4. But in one condition, MCPBA, which is an electrophilic reagent, and our alkene is a highly deficient because it is connected to alpha beta unsaturated ketone. Dr. Anand sir have already discussed about to carry out epoxidation of electron rich alkene, we can use a deficient reagent, that is electrophilic reagent metachloroperbenzoic acid. However, if your alkene is electron deficient, then you have to use electron rich per acid, that is hydrogen peroxide NaOH. And once that alpha epoxy ketone formation takes place by means of hydrogen peroxide and NaOH, alpha epoxy ketone, then tosyl hydrazide. Here tosyl hydrazide is there, formation of tosyl hydrazone, protonation, ring opening takes place, formation of ketoalkyne, and that reduction of ketoalkyne by means of Lindlar catalyst resulted into the Z alkene along with ketone. My dear students, you can learn this reaction, that is Ishii-Moser-Tanabe fragmentation reaction, because this reaction is very much useful reaction. Okay. Sorry, first time I am discussing like this way without any board, because I don't know why the whiteboard is not working. I don't know. I don't have any reason for today. Now, this is a beautiful question I get. Okay, this transformation, you can think about the transformation. First of all, look at towards the starting material. What is the starting material? There is amide and there is ester group is there. In the product, reduction of this amide to amine takes place, and that ester group is converted into ketone group. First of all, you should know the reagents and see why I have considered this particular topic over here. If you go through the question paper of NET examination, that is C section, you have to attempt 20 questions from the organic chemistry section are there, and out of 20 questions, minimum 16 questions are related to multi-step organic transformation. And to solve such type of questions, there is a need of n number of reactions, n number of rearrangements, and n number of reagents. Okay, and to carry out such type of transformation, you should have a practice of solving such type of problems. Okay, now how to solve this particular question? Do you have any answer in chat box? Meantime, you may have discussed, you may have thought how to convert this starting material into product. What kind of reaction condition one has to use? Definitely, I will discuss orally why other reaction conditions are not suitable to convert this A product to B product. Okay, say what is your answer? Yeah, what is your answer? Some of the students, they are giving answer. Yeah.
Students, try to solve the question that sir are asking.
Yeah, somebody has given the answer C, somebody has given the answer B. Okay, then any other choice?
Student, try to solve out the answer.
Yeah, C, answer they are giving.
Yes, sir. C.
Yeah. Some of the students means they know this chemistry. Just I will discuss. Okay, why not remaining answers? No, there is no A, B, C, D. C. There is no A, B, C, D in the answer. There is a 1, 2, 3, 4 is there. There is a 1, 2, 3, 4. Okay, that is the biggest mistake students are doing. Biggest mistake. See over here, 1, 2, 3, 4. That is the answer. Now somebody have written the third answer. That is the, we will see. See, if you choose A answer, sodium borohydride BF3 threat, methyl magnesium bromide THF, then S3O positive. Now, we know very well sodium borohydride BF3 threat can reduce ester group to alcohol group, primary alcohol. Okay. This reagent does not reduce this amide to amine. Okay, that's why even though if you have used a methyl magnesium bromide for the treatment with ester, then you will have a tertiary alcohol. Means this reaction condition is not suitable reaction condition. Okay, then we will talk about the second reaction condition, borane. As you know, what is the role of borane? Borane THF complex or borane DMS complex. See, this borane is used for the reduction of carboxylic acid to primary alcohol as well as for the reduction of amide to amine. Listen carefully, my dear students. Reduction of amide to amine into corresponding amine. See, this reaction condition is suitable. We will have this amide. Then B condition is methyl lithium 2.5 equivalents, THF, then S3O positive. Methyl lithium will react with ester. It will form first ketone and then tertiary alcohol. Means this second reaction condition is also not suitable reaction condition. Then we will think about the fourth reaction condition. Fourth reaction condition, that is trimethyl aluminum, MeNHOMe. Then methyl magnesium bromide, THF, then S3O positive. What will happen? It will form this amide over here and then reaction with methyl magnesium bromide. It is also not suitable. This methyl magnesium bromide also reacts with amide as well as this amide. That's why we can remove that fourth option quickly. Now only third is remaining, and how we can choose that third option, that is borane THF. Borane THF will reduce this amide to amine, no doubt. In the B step, first step is a hydrolysis, NaOH, hydrolysis of this ester group to carboxylic acid. Now we have carboxylic acid plus this amine and then reaction with methyl lithium. That carboxylic acid will react with 2.5 equivalents of methyl lithium. See, when any carboxylic acid on reaction with 2 equivalents of methyl lithium, then it will form corresponding ketone. Benzoic acid is the example, you will get acetophenone. Because first equivalent of methyl lithium will abstract the acidic proton, that COH proton, formation of O minus Li plus. And second, methyl lithium will react with that carboxylate ion and formation of ketone takes place. That's why this third option is the correct option over here. Okay, then we will have another similar type of question. Yeah, we will skip this one. Yeah, now this is the question have been asked many times in the NET examination for 4 marks. See, the structures are big, no doubt. The reaction conditions which you have studied so far are same one. See, for first transformation, we have this aldehyde group, we have this benzyl ether, there is some cyclic sugar, don't worry. Which on reaction with ammonium chloride, sodium cyanide, S3O positive, A product you have to find out, then followed by reduction, that is lithium aluminum hydride, then acetic acid is there, you have to find out B product. Now, what is the first name reaction? Can you have answer in chat box? Can you have an answer for the first step, whatever first step is there? Name of that reaction. Reaction of aldehyde with ammonium chloride, sodium cyanide followed by hydrolysis. What is the name of that reaction? Yeah, somebody have written the name of the reaction, Straker amino acid synthesis. Good. Straker amino acid synthesis, one of the or first multi-component reaction. First multi-component reaction, that is reaction of carbonies with ammonium chloride, sodium cyanide followed by acid hydrolysis or base hydrolysis. It leads to alpha amino acid. And that is Straker amino acid synthesis. This is the first multi-component reaction. Here, okay. Now, if you have solved the first answer A means formation of alpha amino acid. See, this sodium cyanide, ammonium chloride, formation of imine, then cyanide, alpha amino nitrile, and that alpha amino nitrile on hydrolysis, which forms that alpha amino acid formation takes place. Then you have to find out in which case alpha amino acid is there. Now we have in first case as well as in the third case. Means we can remove 2 and 4. We can remove 2 and 4 quickly. Now what is remaining? We have a first and third. We have first and third. Okay, now what is second step? Lithium aluminum hydride reduction. What will happen in lithium aluminum hydride reduction? It will form reduction of this carboxylic acid into alcohol. Okay, reduction of carboxylic acid into alcohol formation takes place, means CH2OH and here NH2. Okay, then followed by, see, this is a critical and important step. Followed by, now means you have a primary alcohol, CH2O is there, here also CH2O is there, followed by acetic acid. Followed by acetic acid. And if you are considering that third answer is correct, then it is totally wrong. Then it is a totally wrong because to carry out O acylation, it requires acetyl chloride. To carry out N acylation by means of acetic acid, there is a need of some kind of catalyst as well. Okay, that's why, see, the formation of 1,2-amino alcohol followed by reaction with acetic acid, formation of such type of product takes place. If you have a mechanism, see, amide formation takes place, means NH double bond O, CS3, and that O will attack on that carbonyl, that imine formation takes place. And this is your answer. First answer is the correct answer. Is through this example, what we have learned? We have learned Strecker amino acid synthesis followed by reduction with lithium aluminum hydride and then cyclization reaction. This is the question for 4 marks. And if you know this chemistry, you can solve within 1 minute. And how to remove wrong options from the answer, that is also important thing. Then, okay, now. The major products, as yesterday or today also in the morning session, resource person have talked about some of the questions are related to research, recent research, no doubt. They are asking some of the questions related to research. But if you know the fundamentals of some of the reactions, if you have studied some of the named reactions very well, then you are able to solve such type of questions. Okay, to solve such type of questions. Now, see what is there. This aldehyde is there, some aldehyde is there. This aldehyde on reaction with carbon tetrabromide, triphenyl phosphine, followed by excess of N-butyl lithium, formation of A product. And that A product on reaction with the phenyl azide in presence of copper sulfate and sodium ascorbate, what will be the B? Yes. Now, I want to ask.
Students have given the answer 4.
Yeah, those students have studied that reaction. That's why they are giving answer 4. But it's my duty to explain why that answer 4 is correct. Why not first, second, and third? Okay, that is important thing.
Yes.
See, the named reactions, I think in your university's curriculum, this reaction is not there. Definitely. And this answer, definitely this answer from our university student. Okay. Ma'am, I can ask, or those who belongs to organic chemistry section, whether there is one named reaction in your curriculum, that is Core-Fuchs reaction. Core-Fuchs reaction.
I'm from physical chemistry, sir, and rest
Yeah,
of inorganic chemistry.
Yeah, those who belongs to organic chemistry section, just can they tell me whether in your curriculum this Core-Fuchs reaction is there? I think it is not there. I have gone through the syllabus of all the universities of Maharashtra. I know very well this reaction is not there. Okay, that's why my suggestion, because 3 times the question have been asked on Core-Fuchs reaction. It is similar to Wittig reaction. It is similar to Wittig reaction because carbon tetrabromide and triphenyl phosphine, my whiteboard is not working. Otherwise, I have discussed the mechanism very well over here. Okay, carbon tetrabromide, triphenyl phosphine, excess N-butyl lithium, formation of alkyne takes place. And those who know this reaction, they can solve this particular problem quickly. Formation of this 1,4-disubstituted 1,2,3 triazose. It is nothing but cycloaddition reaction of terminal alkyne with azide in presence of copper sulfate and sodium ascorbate. And this reaction is a click reaction. This reaction is a click reaction. Click reaction is nothing but reaction between terminal alkyne with terminal azide, formation of 1,4-disubstituted 1,2,3 triazose over here. Okay. Now we can have this question. read question, take 2 minutes to solve this particular problem. Yeah, and definitely I will tell you what could be the answer. Yeah, I'm expecting answer from your side, students. Hello? What could be the answer?
Answer that is option number 4.
Okay, yeah. See, benzaldehyde, which on reaction with this phosphorus halide, this phosphorus halide is a stabilized phosphorylide. Stabilized phosphorus halide, it means that it will form E-alkene, not a Z-alkene. E-alkene, not a Z-alkene. Okay, one thing. Once you got this particular idea, then you can able to solve this question. Okay, this is the first point I want to tell you over here. This is the example of Wittig reaction of this benzaldehyde with PS3P double bond CaCO2 means it will form ethyl ceramide. And this ethyl ceramide on reduction with lithium aluminum hydride in ether at -78°C. It means that formation reduction of that ester group by keeping intact that double bond. Means double bond will not reduce under this condition because -78°C is there. That's why if you don't know remaining things, accordingly you can solve. See over here that trans-ethyl ceramide, which on reduction by means of lithium aluminum hydride, which will form alcohol. Here this is the alcohol, not a Z alcohol. See here Z alcohol is there, and here complete reduction. Complete reduction is not possible. At higher temperature, reduction of double bond may take place. That's why reduction of this ester group into alcohol, and remaining thing is protection of that alcohol by means of tetrahydropyrin ether. This is the dihydropyrin under acidic condition, formation of tetrahydropyrin ether, which gives this particular answer. Okay. Now we can have another question. See, I will cover such type of questions which have been asked for 4 marks and such type of questions about 60 to 65 marks we will get from C section of NET examination. And in SET examination, very simple questions have been asked. Yes, what is your answer? Just quickly.
Answer 3 is given, sir. Option number 3.
Yeah. Answer 3 is given. Okay. 3. Why 3? Why not 1, 2, and 4? We will discuss like that way. Why not 1, 2, and 4? Okay. See, if I take one answer, A reaction condition is a lithium aluminum hydride. Students of organic chemistry, they know lithium aluminum hydride reduces ester group as well as carboxylic acid, and we don't want that kind of reduction. Okay, we don't want that kind of reduction. Means how many options we can remove quickly? We can remove this one option and 2 options because lithium aluminum hydride is given in both the options. Dear students, see, means lithium aluminum hydride reduces ester group as well as carboxylic acid group. That's why reduction of both takes place. Means 1 and 2 we can remove quickly. Now we will focus on 4th. A condition is boron DMS, boron, and B condition is lithium borohydride. Okay, A condition. What is A condition? What is there in A condition? Reduction of ester group. Reduction of ester group in presence of carboxylic. And for B condition, reduction of carboxylic acid in presence of ester, means selective reagent we need. And this boron, what boron will do? Boron will reduce carboxylic acid in presence of ester. Boron will reduce carboxylic acid group in presence of ester. Here, reduction of ester group in presence of carboxylic acid means lithium borohydride can work over here. Reduction of ester, then cyclization takes place. And here, see B condition, reduction of carboxylic acid, that is CS2OH, and that CS2OH will attack over here and formation of this cyclic compound like that way. Means if you know something, then accordingly we can choose, but behind this lot of chemistry is required. Behind this lot of chemistry is required. It is not an easy job. Okay. Then the next question, see carefully. Yeah, you can take 2 minutes minimum to read this question. Yeah, and tell me your answer. Yeah, what is your response? Think yourself. Definitely everyone have studied this particular transformation, such type of transformation. Yes, what will be the answer? Yeah, somebody have written first one. First one. Yeah, somebody have written first. Okay. Then
They want to take a time of 2 minutes, sir.
yeah, definitely, because they want to grab 100% mark.
Yes.
100%.
4 is there.
4 is there. Okay.
Again 4 is there.
Yeah, someone has written 2.
2, 1, everything is there.
Yeah. But it should not be like that way. See, there should not be any kind of variation. Yeah. At the last, some answer is coming means they are writing correct way. Yeah. See over here how to solve this particular problem. It's a very easy job, and through this transformation we can learn many more things. Orally I will tell. Otherwise, by mechanism I can write each and everything, but it was not possible today. I don't know the reason. But first thing, phenyl magnesium bromide, which will form tertiary alcohol. Phenyl magnesium bromide, which will form tertiary alcohol. Once that tertiary alcohol formation takes place, followed by reaction with PTSA. The reaction with PTSA means dehydration takes place over here. Dehydration of that tertiary alcohol means there are 3 choices: 1, 3, and 4. We can remove 2 quickly because 2 into tertiary alcohol is there. But later on, dehydration takes place over here. Okay, dehydration. And that's why we can remove these 2 options quickly. Now we have 3 choices, and among these 3, we have to choose proper one. Okay, how to choose? Then alkene, whatever alkene we got, that on hydroboration reaction. That on hydroboration means formation of organoboron reagent, and you have to know about Markovnikov rule or anti-Markovnikov rule. Okay, Markovnikov rule or anti-Markovnikov rule. Okay, in hydroboration, we will get BH2 over here. BH2 over here. Yeah, okay, I can write over here. See, if you are getting this alkene once that dehydration. See, dehydrated product here pH, and this out reaction with the boron. See, boron dimethyl sulfide. We will have a corresponding boron here pH and here BH2. Okay, now we have this organoboron reagent. Then What could be this one? PCC. As we know, we should know the applications of PCC. One application for the oxidation of alcohols. Okay, we know for the oxidation of primary alcohol to aldehyde, secondary alcohol to ketone, allylic tertiary alcohols to alpha beta unsaturated ketone. These are the some of the applications of PCC or PFC. Then another application of this PCC, it oxidizes organoboron compound to carbonyl. Means this on oxidation by means of PCC. You will have a C over here. You will have this PH and here C double bond O. Means 2-phenyl cyclohexanone formation takes place. 2-phenyl cyclohexanone formation takes place. Okay. Now see, later on, we have finished up to this step. Now last step is MCPBA, and in the morning you have studied metachloroperbenzoic acid and migratory aptitude also. Because see, once this intermediate formation takes place, suppose this O minus, this O, this O, C double bond O, this aromatic ring is there, and here pH group, this is the intermediate, and once this intermediate formation takes place, then either migration of this methylene group or migration of this group takes place. This will migrate towards this side, elimination of that carboxylate anion takes place, and now means there is no any epoxidation. It's those people, those who have given answer this 4, that is the wrong one. Now the 2 options are there, 1 and this third. In third option only ketone, it is stopped at ketone state, but later on MCPBA is there. Okay, that's why if you know, then this answer is a correct answer. Okay, this answer is a correct answer over here. Okay, now we can have another one. Yeah, very beautiful problem. Yeah, you can take some time to solve this particular question. Yeah, 2 to 3 minutes you can take to solve this particular question. And I'm expecting answer from your side. Yes, somebody have written the answer A, somebody have written answer 2. Okay. 2. Definitely these people's 2. Okay. Yeah. See, but why? That is important question. To solve this particular problem, one has to know first Birch reduction. Okay. Birch reduction of aromatic compound, and there is a 2 groups. Both the groups are electron donating groups. Okay, both the groups are electron donating groups. They are meta to each other. And what kind of product we can expect? See, the product of this first step, this A, everyone knows about Birch reduction. And when this question was asked in the examination, 2 times this question was asked, and when it was asked the first time in the year of 2012 or 13, before that one we have conducted this same problem in our university department. Okay, we have asked the same problem for our university examination, and later on lot of deliberation, lot of discussion was there why that answer is correct answer. See, the product of first step, just I will write over here. It will have the reduction takes place at 2 position, here CS3 and here OCS3. Okay, means here H, and here H and H. And what kind of answer is there? Here 1 and 3 answer. Okay, only 2 choices are there. Remaining 2 choices are wrong choices. Sorry, this is not there. This will be. Yeah. Okay, means only 2 and 3 are correct. But later on, morning we have seen if monosubstituted alkene and suppose disubstituted alkene is there. Okay, or not only in this example, if suppose this kind of compound is there, you can have a double bond. This on oxidation by means of metachloroperbenzoic acid. Epoxidation of this alkene takes place because there is a presence of additional one electron donating group, because we are using electron deficient per acid. Electron deficient per acids. That's why electron rich species will get oxidized very fast than less substituted double bond. Here there are two choices. This is the double bond, this is double bond. Okay, in both cases. Okay, then see, due to presence of this methoxy group, this alkene is a more electron rich alkene as compared to this one, because this group is electron donating, more electron donating as per plus R effect. Plus R effect. That's why epoxidation takes place towards this side, not towards this side. That's why your answer will be this answer, not this answer. Okay, now you got this answer correctly. Now, a very beautiful problem again. Yeah, similar type of question in the morning session, Dr. Anand sir have discussed. See, meantime, you can have a choice. You can take 2 to 3 minutes. Just I will read the question. Read the question. I will not ask what is the name of this compound. What is the name of this compound? Just this starting material is alpha beta unsaturated ketone. It is called as carbon. It is a terpenoid, monoterpenoid carbon. See, in A transformation, this alkene gets converted into cyclopropane in A transformation. In B transformation, this ketone gets converted into oxirane or epoxide with one more additional carbon is there. And in the C transformation, selective cyclopropionation reaction. Selective cyclopropionation reaction takes place over there. Okay, now we will go one by one. We will come from fourth point. Okay, from fourth point. Why that should be fourth is the correct one. We will have that one. Okay, see, in fourth one, I think in every university of Maharashtra, they have a sulfur ylides. Okay, sulfur ylides. Every students of Maharashtra University, they are studying sulfur ylides. But the students of Amravati University, whether they have studied the name of that reaction, can you have answer from Amravati University student? Like for phosphorus ylides, we are calling Wittig reaction. Okay, Wittig reaction or Wittig-Horner reaction or Horner-Wordsworth-Emmons reaction. Like that way, whatever sulfur ylides we are using, what is the name of that reaction? Can you write in the chat box? Can you write in the chat box, students of Amravati University? It may take half a minute to write the answer for this question. Sulfur ylides, which you are studying, do you know the name reaction related to sulfur ylides? Okay. No one has written so far. Okay, somebody may have written, yeah. Somebody may have written, I don't know. But she is from our university. She is from our university. I am asking about the students of Amravati University. Yeah, both the answers, whatever answers, both are students from our university. Yeah. It's okay. See, this is the beautiful example. And even though we are studying sulfur ylides, but we don't know what named reactions are involved in sulfur ylides. What named reactions? And these type of questions, every 2 years, you will see one time such type of question is asked. One time. Just a small modification in the example. See, now we will come from the last option. This is a stable sulfur ylide. Morning we have seen stable sulfur ylide, SSY. This is the unstable sulfur ylide. Have you studied Tebbe's reagent? Students, Tebbe's reagents. Tebbe's reagents is nothing but cyclopentadienyl titanium, Cp2 Ti double bond CH2. This is the methylide cyclopentadienyl titanium reagent. Okay, and role of this reagent like Wittig reaction. Like a Wittig reaction. If suppose I have not studied properly that particular sulfur halide, then also if I know Tebbe's reagent, this Tebbe's reagent, I can solve this particular question. Okay, means the sulfur halide which is derived from DMSO, they are stable sulfur halide, and the sulfur halide which is derived from DMS, that is dimethyl sulfide, which is unstable sulfur halide. Okay, no doubt both the halides are used for the conversion of ketones to epoxides. But some condition is there. If the ketones are saturated ketones, then only both the halides gives oxidants or epoxides. If alpha beta unsaturated ketone is there, this halide gives cyclopropentine, and this halide gives epoxide. Okay, this halide gives cyclopropentine. Okay, cyclopropentine. Okay, if the starting material is alpha beta unsaturated ketone. Now accordingly we will see. A condition, stable sulfur halide. Yeah, it is true. B condition, unstable sulfur halide, which also produces epoxide. That is good. But what about C? This Tebbe's reagent which is not useful. Okay, Tebbe's reagent which is not useful. That's why we can remove this one. Okay, C. Now we will come towards the third. In third, A condition, CH2I2 zinc copper couple. That is a Simon-Smith reaction. Which is used for this cyclopropionation reaction. And in A condition, cyclopropionation is there, but the starting material is alpha beta unsaturated ketone is there. Okay, that's why we can remove this one also. Now we will have this second choice. In second choice, this unstable sulfur halide is there in A condition. That unstable sulfur halide which is used for the conversion of ketone to oxidant over here, means like this way. Means we can remove this one. Accordingly, this stable sulfur halide which will form cyclopropentine. Okay, no doubt your C choice is correct, but these two are wrong. Then we can go for this first one. We can solve this particular question. C option, C Simon-Smith, correctly. Cyclopropionation reaction takes place here. Okay, B, sorry, just I have to come back. Yeah, it is there. In B choice, unstable sulfur halide, which is used for this epoxide formation of ketone group, which only oxidize this ketone group to epoxide formation takes place over here. Means this is correct one. And for A, this one, cyclopropionation reaction takes place. Do you understand this problem? Somebody has written option 2 is correct. No. Why option 2 is correct? Because in B condition, this stable sulfur halide is there. This is wrong. Whoever is there? Jamir. You know very well. You have listened me several times, Jamir. Yeah, this is wrong. Yeah. Do you understand? And the name of this reaction I want to tell you, Korey-Tchaikovsky reaction. Korey-Tchaikovsky reaction. Korey-Tchaikovsky cyclopropionation reaction. Korey-Tchaikovsky epoxidation reaction. Okay, these reactions are very much important. Korey-Tchaikovsky. Yes. Yeah, now we will have another problem. Yeah, now you can take 2 minutes. You can take 2 minutes to solve this particular question, because we have to qualify NET examination. SET is very much easier as compared to NET. Because there is a limited syllabus in SET examination, very limited syllabus. And very simple questions have been asked in the SET examination. Yeah, take your own time. What kind of answer? and what kind of trick one has to use.
Four is given, sir. Answer 4 is given by the participant.
Yeah. Why 4? That we will discuss. Why not 1, 2, 3, 4? Okay. See, because we have ample space over here. It is nothing but this is the example of Gilman reagent. Okay, Gilman reagent. That Gilman reagent is used for 1,4 conjugate addition reaction. 1,4 conjugate addition reaction of organocopper reagent. Organocopper reagent. Okay. Now see here, reaction of methyl magnesium chloride with copper chloride. With copper chloride, it will form that respective organocopper reagent, or activation of this carbonyl group by means of CuCl and this methyl magnesium bromide chloride. Rather than reacting on this carbonyl group, it will react on this one beta position. Means that methyl group will go at this position. Methyl group will go at this position. See, my dear students, that methyl group at this 4th position in 2 options only. In 2 options, this one and this one. See how we can remove quickly the 2 options. See, we have removed 2 options. Now among these two, we have to find out correct choice over here. See, now see what is the first step. We will have the first step. I will write over here. Here double bond. Here carbonyl will be there, and here just without writing the stereochemistry, I will write PHCS3. Okay, see over here. No doubt these electrons will go towards here. This will go towards here. We can have a resonance structure. Here O minus, here CS3, and here pH is there. Again, it will come back and reaction with this allyl chloride. Rather than getting O alkylation product over here, we will have a C alkylation. Rather than getting O alkylation, it is there. Sorry, O alkylation, it is there. But it is not a stable one. That's why this is the correct answer. Okay, correct answer means 1,4 conjugate addition reaction followed by alkylation reaction. 1,4 conjugate addition followed by alkylation reaction. Okay. Now, yeah, my dear students, you can take your own time. Yeah, you can take 2 minutes, no problem. But you have to solve correct. Yes. Good. Everyone is giving answer 4. Okay. एकाने दिले की सगळेजण देतात त्यात काही वादच नाही. Yes. Okay. Why not other options? See over here. Just I will keep this chat box aside because I will get some white space over here. Yeah. See, why not this answer? Okay, we will discuss about this one. See, this trimethylsilyl CH2OMe, what it will do? It will form carbanion over here, Me3, this SiCH minus OMe. Okay, and this out reaction with, yeah, just a minute. Yeah, just a minute. Yeah, we can have another trick over here, but it is not possible to have that answer. See, Me3 Si, this CH minus OCS3. This is the product of first step. Okay. And then what it will react with carbonyl group? Okay, it will react with carbonyl group. See, cyclohexanone. This will react with cyclohexanone. It will form, just I can write directly product like C over here, double bond. Here, this OH, this CH, okay, this Si, Me3, and O. Okay, okay, I will write over here. Here, we will have a O minus, here CH, this Si, that SiMe3, OMe is there. Okay, now SiMe3 is there. What it will work in further steps? See, in the next step, what happens? Either this elimination may take place, or you may have a formation of such type of products, that is CH double bond OCS3. Okay, and what will happen after hydrolysis? You will have a aldehyde. Okay, this hydrolysis step is there, and then sodium borohydride is there. You will have a alcohol CH2OH. Formation of CH2OH takes place over here. Could I remember? Formation of CH2OH. But we need double bond over here. This is not a suitable reagent. This is not suitable. Similarly, we will think about this particular reagent. Okay. See, this is a phosphorus halide. And when reacted with carbonyls, we will have a same type of product. If you have carry out Wittig reaction, you will have the same product over here. And after hydrolysis, you will get aldehyde, and that aldehyde gets reduced into alcohol. Okay, now we can remove these two options quickly. Then next option, we can have this option. We can check this option. It will form tosyl hydrazole. Okay, NHTS, tosyl hydrazole. Then this tosyl hydrazoles on reaction with sodium ethoxide. Sodium ethoxide, what it will do? It will do formation of sodium salt over here. You may have studied one of the reaction, that is a Bamford-Stevens reaction. Bamford-Stevens reaction. Okay, that formation of carbonyl, it will react with this ethyl chloroacetate. It will form ester group CO2ET. But we need this cyclohexene methanol product now. Now you may have studied this famous reaction, that is a Shapiro reaction. Shapiro reaction. Okay. What is this Shapiro reaction? Reaction of carbonyls with the tosyl hydrazide in presence of acid, formation of tosyl hydrazole, and which on reaction with two equivalents of N-beta lithium, formation of lithium, means vinyl lithium, and that vinyl lithium can be trapped by means of electrophile. That electrophile is a formaldehyde. Now I will write some of the intermediates. The first intermediate is the same, this one. Okay, tosyl hydrazole. Then two equivalents of N-beta lithium means it will form this lithium salt, here lithium, and this lithium on reaction with formaldehyde HC double bond OH, you will have a directly cyclohexyl methanol. Means you should have this fourth option is the correct option. Is through this example, we can learn Bamford-Stevens reaction followed by Shapiro reaction, Wittig reaction, and organosilicon compound also. Okay. Yeah. Now we can solve this particular question. Yeah, you can take 2 minutes, and this was the question asked in the NET examination for 4 marks. Yeah, what would be your answer? Just I want to see in chat box. Yeah, somebody have told Peterson-Weyl equation. Yes, that was the example of Peterson-Weyl equation. Yeah. Jamir, yeah, it's correct. Yeah, we want to have an answer of this particular question. Yeah, take some time. Yeah, somebody is saying that answer 4. Somebody is saying that answer 2. Okay, we have to wait for more responses. Yeah, very interesting questions are there. Yeah, again, answer 4, 2. Yeah, somebody have written in details. Yeah, manage reaction followed by Jamir. Yeah, Hoffman, exhaustive. Yeah, definitely. And lastly, substitution. Yeah, okay. Now, most of the answers, there are 2, and some of them are given the answer of 4 as well. First of all, you should know about what happens? क्या हो गया ये? Keep me. Yeah. Oh, just 1 minute. नहीं, लास्ट वाला है प्रॉब्लम, तो हमारा लास्ट वाला है. जाएंगे जब तक पहुंच जाएंगे. हाँ, yeah, am I audible, ma'am? Hello. Yeah. Now, what things one has to know? First of all, this is a pyrrole, and how pyrrole gives electrophilic substitution reactions. There are 2 positions, that is 1, 2, 3, 4, and 5. Electrophilic substitution reactions at 2 and 3 position. Okay. In case of 5-membered heterocycles like pyrrole, furan, and thiophene. Hello. Yeah. This pyrrole gives electrophilic substitution reactions. Oh, sorry. क्या हो गया? Keep. Yeah, इसको ये करना पड़ेगा. Yeah, this pyrrole gives electrophilic substitution reactions at 2 position. Okay, 2 and 5 position. Okay, 2 and 4 position. If 2 position is blocked, then it will go at 5 position. Okay, now see over here. There are 2 choices. There are 2 choices where the electrophilic substitution is at 2 position. Means this one and this one. We will think later on. We can remove this answer and this answer. Okay. Later on, we will see what kind of reaction is there. Reaction is formaldehyde plus dimethylamine. Formaldehyde plus dimethylamine. Okay. Yeah. Madam, आपने तो क्या करी? Rekha, आवाज, please mute yourself. Rekha. Yeah. Okay. Now, then you have to know about formaldehyde and dimethylamine. Means you should know. Oh. Escape.
No, sir.
Yeah. Okay. Yeah. You should know about the managed reaction first. Managed reaction. In managed reaction, formaldehyde and dimethylamine is there. It will form managed base. And as we have seen, this pyrrole, methyl pyrrole gives electrophilic substitution reaction with this intermediate, that is NMe2 here, positive charge, and this H. And this is one of the useful intermediate in managed reaction. And this intermediate is called as Eschen-Moser salt. Eschen-Moser salt. Okay. And managed have utilized this Eschen-Moser salt, which is generated from formaldehyde and secondary amines. Okay. And then managed reaction takes place and it will go at 2 position. It is there in both cases. See, if you know up to this stage, further reaction, methyl iodide, reaction of this methyl iodide with this NMe2 means formation of quaternary ammonium salt. Quaternary ammonium salt. Okay, just I will write that quaternary ammonium salt over here. This CS3 double bond CH2 NMe3 positive charge is there. Okay, then just we have made better living group over here. Better living group. Okay, NMe3 positive is the better living group, quaternary ammonium salt. And then we have a sodium cyanide. Just nucleophilic substitution reaction takes place and it will attack over here. Elimination, nucleophilic substitution reaction takes place. And we will have the CH2Cl is the final product. It should not be. Okay, that's why this is the answer for your question. Okay, now whatever questions we have missed, just I can try like this way. Yeah, okay. Yeah, we can solve this question because this is a beautiful question. Many times asked such type of question in the examination. See, what you have to have a pentanone, 3-pentanone. See, 3-pentanone means it is a symmetrical one. This is the starting material and product is, see, product is 3-ethyl 3-heptene. 3-ethyl 3-heptene means at 3 position the double bond should be there. See, 1, 2, 3. Okay, at 3 position heptene. Heptene means total 7 carbons are there. 1, 2, 3, 4, 5, 6 and 7. Okay. 1, 2, 3, 4, 5, 6 and 7. Heptene at 3 position. 1, 2, 3. At 3 position there is an ethyl group. Now see, this is the final structure of the product. 3-ethyl 3-heptene. Okay, either from this side or from this side. Now we have this one 2-ethyl, this 2-ethyl are there. Here this 2-ethyl, this 2-ethyl are there. Means what kind of ylide is required? Having this much carbon, means 1, 2, 3, 4 carbon containing ylide, and it should be straight chain. Here in first case only 3 carbons are there. Here in second case, see, here 4 and 5 carbons are there. Here only 1 carbon. Here 4 carbons are there. Means accordingly we can solve this type of question. Okay, now we can try similar type of questions over here. Yeah. This is a simple question. Simple question. I can give answer. Yeah. Yeah. Can you have answer for this one? Quickly. Student friends, do you have answer for this one? Yeah. Somebody have given answer 2. Okay, next. Yeah. Okay. If options are not there, how you can solve? If options are not there, how you can solve? This is a simple question. What will be there? See, first step, sodium ethoxide ethanol. What it will do? Simply see here. Once again, I can write OET, here CO2ET, formation of carbonyl over here, and methylation takes place over here. We have methyl chloride. Then see, this is geminal diester. Hydrolysis of this geminal diester by means of acid means formation of this COOH, here COOH, and here methyl group is there. Now heat is there. Heat, geminal dicarboxylic acid, decarboxylation takes place, and formation of C minus CO2. You will have a COOH, and here methyl group is there. How many carbons? 1, 2, 3, 4, 5, 6. And the methyl group is at 2 position. It means that 2-methyl hexanoic acid. 2-methyl hexanoic acid is the answer for this question. Okay, there is no need to write these particular problems again. Just I will escape, and we will have some another beautiful problems. Just 1 minute. अभी क्या करना पड़ेगा? Keep. नहीं, हमें अभी एक नहीं न्यू स्लाइड, एक ब्लैंक स्लाइड यूज करेंगे हम. या ओके, इसको हम लिख सकते हैं. Yes. Now we can have some another questions. My tab is not working, but I'm using some other techniques also. How to solve such type of problems? Okay, which is a very much interested problems over here, and we can take one by one some of the problems which we have already covered, but some of the problems are very much important. Okay. Now see, I will write partial question, not in detail, because to write all the questions is a difficult task. But I can manage here CHO, and at meta position there is OH. Okay, and this is converted to here CH2OH. Here, oh, क्या हो गया? Yeah, okay. Oh, yeah, this is the problem. Okay, if such type of question we are asking in the examination, suggest suitable reaction conditions for the following transformations. Suggest suitable reaction conditions in our university examination. Okay, see, in the starting material, aldehyde group, in the product, primary alcohol. Here, secondary alcohol, here secondary alcohol, but complete inversion of configuration is there. Okay, accordingly, the conditions, just I can write the conditions. In short, what kind of conditions we can have? This is first reaction condition, A, POCl3, then pyridine. B reaction condition, silver acetate, AgOAc, and C reaction condition, that is lithium aluminum hydride. Okay, 2 reaction condition, 2 in A, sodium borohydride, then B, triphenyl phosphine, dead, and pH CO2H. Third, in third case, A condition, triphenyl phosphine, dead, okay, then pH CO2H, Okay, and B is lithium aluminum hydride. And fourth one, C, A condition PCC, and B1 is L selectride. Okay. Now, yeah, Jamir, I know very well. Huh? Yeah, see how to solve this particular question. You have ample time to write this particular answer, correct answer. You can consider by one color only. I have written. See, many students, they are saying that the answer 3 is correct. Why 3 is correct? Why not remaining are here? Okay, we will discuss accordingly. See over here, POCl3 and pyridine, what it will do? Here, dehydration may take place. See, dehydration, elimination type of reaction. Followed by silver acetate, no doubt diol formation takes place. Diol, as in the morning, that Woodward and Prevost hydroxylation reaction, silver acetate, silver benzoate we can use, but partial reaction condition is provided here without iodine. And lithium aluminum hydride, we don't want diol over here, that's why we can remove this condition. Okay, then means we can remove this first one. We can have this fourth one, PCC. What it will do? PCC will oxidize. Means it will lose its chirality. Okay, it will lose its chirality, and then we are reducing that ketone group by means of L selectride. L selectride, no doubt, it is a bulkier selectride, no doubt, but you will not get a single enantiomer. You will not get a single enantiomer, you will get a racemic mixture. That's why this is also not suitable reaction condition. Okay, then we will go for 2. This sodium borhydride, no doubt, it will reduce this aldehyde group. Reduction of this aldehyde group. Then we have a competition between this primary alcohol and this secondary alcohol. Okay, with this TPP, triphenylphosphine, dead, and PHCO2H. Okay, means you will have that CH2 OCOPH, means benzoate ester derivative will be there in both cases, and we want alcohol in the final product, means we can have this option is a wrong option, and this one triphenylphosphine dead, benzoic acid followed by reduction, that is nothing but Missonobu reaction. Okay, Missonobu reaction. Okay, Missonobu reaction, that is used for the complete inversion of configuration. Complete inversion of the configuration. Okay. Now we can have another one. Keep next lena hai. Yeah. Now see, means we can have that Missonobu reaction as well. Now, simple problem I can take. I can discuss with you regarding the transformation. Okay, I will not write options over here because it may take a lot of time to draw the options. Just I will write the question and yeah, I will play the slide. Yeah, we can have the structure that is indole, NH. And that indole is connected to furan. Okay, this out reaction with DMF POCl3 1 equivalent. DMF POCl3 1 equivalent. In first transformation, what will be A? And in this case, DMF POCl3 excess amount B. Okay, now can you suggest me the answer for this question? Do you have any answer? See, first of all, it's difficult to draw all the options over here. It may take 3 to 4 minutes. See, DMF POCl3, this is the reaction condition used for Willsmere-Haack formulation reaction. Willsmere-Haack, Haack formulation reaction. Means we can introduce formyl group with the help of DMF and POCl3. Okay. एवढंच माहिती असून उपयोग आहे का? नाही. You should know about the electrophilic substitution reactions on indole as well as furan. Okay, no doubt. But this indole and furan in the same molecule again. Okay, then which one is a more nucleophilic in nature? Either indole ring or furan ring. That is important. Okay, because one equivalent is given over here, and there are two choices. Just I can write for A option. Okay, A option. This NH, this O here. See, as we know, this furan ring on electrophilic substitution reactions at 2 position, and this indole ring now at 3 position. There is a competition. Either furan will get first formulated or indole. What is your reason? Can you write answer? Furan or indole? Yeah, can you have in the chat box? Furan or indole? Then we will see later on about the two equivalents. No answer? Yeah, somebody have written indole. Yeah, okay. I can understand your feelings. If you have studied heterocyclic compounds very well, heterocyclic compounds from heterocyclic chemistry from Joule and Mills book, or if you have studied from Leo Packet, okay, Leo Packet, not from R.R. Gupta and all. Okay, see, the first formulation will take place of indole ring. First formulation. See, it means that will be the A product, and second formulation definitely will go in furan ring at 3 position. Means this is the final product of the reaction. Okay, means we have to know about this one. Okay, yeah, now simple problem again it is there. How to write the answer, quick answer of the question. Just wait 1 minute. Small question I used to take. Yeah, morning Dr. Anand have talked about some of the oxidation. Okay. See, benzaldehyde is given. Oh, sorry. Benzaldehyde is the starting material. This out reaction with first. This is reacted with thiazole. Here positive charge. So N-methyl group is there. I minus followed by base sodium methoxide, and second step you will have a furfural-aldehyde. Okay. Now, a beautiful reaction. What could be the name of this reaction? Can you have name of this reaction? I can expect answer from your side if you have prepared organic chemistry from quality books. Yeah, correct. Because see, this thiazolium salt is there, and it works like unpolar reaction. Means you will have a benzoin type of mechanism. Benzoin type of mechanism takes place over here, and accordingly you will get a respective product like C double bond O, here OH. Just I am writing final product. Okay, this is the example of benzoin condensation. Good. This is the example of benzoin condensation reaction. That is true. Now I can have another simple example. Okay, yeah, it is there, but yeah. Yeah. Now I will write, and accordingly we can have answer. See, I am providing you starting material, benzaldehyde. This benzaldehyde on reaction with TMSCN, comma, zinc iodide in catalytic amount. This is the first step. In second and first again, LDA, morning session, you have heard about LDA, that is lithium diisopropylamide, pH of minus 78 degrees Celsius to room temperature. And B is isopropyl iodide. Third step, again, A, H positive water, and B step, that is aqueous NaOH. Okay. Now this is the reaction condition. Okay. If suppose similar type of questions we are asking in our university examination, predict the product with mechanism. Okay. Without answer, we are not providing any kind of answer. But because of this COVID-19 pandemic, all the examinations are through MCQ pattern. Okay, just I can provide you answer. This first answer is a pH OTMS. Okay, this isopropyl group. Then two answer, alcohol. Third answer is pH, and fourth answer is pH C double bond O, isopropyl group. Now you can have a choice. The job becomes very much easier. Can you solve this question quickly? Yeah, good. See, if you have solved in correct way, you will get 100% marks. If you know the chemistry. Okay, now everyone have given answer 4, but why not 1, 2, 3? Okay, why not 1, 2, 3? See over here. The first step is reaction of benzaldehyde. Okay, I will use this space, benzaldehyde with zinc iodide and TMSCN. This zinc iodide will activate the aldehyde group. And formation of this one PHC. This is CN, here OTMS, and here H is there. Okay, this is the product of first step. Then second A, what it will do, that LDA will abstract this acidic proton. Okay, LDA will abstract this acidic proton. It is like benzoin type of reactions. Exactly. It is like a benzoin type of condensation. Abstraction of this proton by means of LDA takes place and followed by reaction with isopropyl iodide. Means we will have this one pH, here OTMS, this Cn, and C here, this isopropyl group is there. Okay, okay. Now, then the next step is H positive. What it will do? Cleavage of TMS ether, trimethylsilyl ether formation takes place. Cleavage means it will form cyanohydrin. Okay, formation of cyanohydrin takes place. Oh, just a minute. Formation of cyanohydrin over here, PH, here OH, and this Cn, and this isopropyl group is there. And under basic condition, NaOH, that will abstract this proton. These electrons will come towards here, elimination of cyanide group and formation of PHC double bond O, this one. And that's why fourth answer is correct. Remaining, this is the intermediate. Okay, this never intermediate. Okay, this is also not intermediate any kind of, and this is not also intermediate for this one. Okay, now I will take some another slide. Yeah. Okay. See, now I will write the structure cyclohexanone. Okay, cyclohexanone on reaction with dimethylamine, formaldehyde, H positive. This is the first step. Second step, methyl iodide and NaOH. And this is the A product, methyl iodide, NaOH. And this on reaction with sodium cyanide, heat, B product. Okay. Am I audible?
Yes.
No? Yeah, sorry. Yeah. Because I could not see your chat box, that's why. Yeah, see, now can I provide options to you, or shall I discuss this question? Okay, if I provide the options, it may take 4 minutes to write. Okay, but we can have a see over here. This is the reaction condition used for managed reaction. Okay, first of all, you have to know managed reaction on cyclohexanone. It will have a managed product over here. C double bond O, CH2, this NME2. Okay. Now followed by methylation. C over here. This methyl iodide. Oh. This methyl iodide will be there. C double bond O, CH2, NME3, formation of quaternary ammonium salt. Here, then sodium hydroxide is there. That sodium hydroxide will abstract this proton, and this will come towards here. Elimination takes place and formation of methylidine cyclohexanone. Okay, means that is the A, methylidine cyclohexanone. And this methylidine cyclohexanone on reaction with sodium cyanide, this is a C triple bond N. This nucleophile is a soft nucleophile. It never gives 1,2 addition product if the substrate is 1,4 alpha beta unsaturated ketone. It never forms cyanohydrin. Okay, that's why it will see, it gives a Michael addition type of product over here. That is C triple bond N, and we will have a respective product that is C double bond O, CH2 Cn, rather than 1,2 addition product over here. Okay. Yeah, it never reacts with this carbonyl group. Okay, it never reacts with this carbonyl group. That's why it gives 1,4 conjugate addition product over here after filtration. Okay. Now, I will select new slide. Yeah, another simple problem is there. It's similar to this one. I can have a See, again benzaldehyde is there. Benzaldehyde. Okay, NaCN, MnO2, A question mark, and NaOH question mark. Sorry, B is there. Okay. What kind of product do you expect over here? Yes, which named rearrangement is involved over here? Can you write in the chat box? Can you write in the chat box? लिहिलं का chat box मध्ये? एवढा सिंपल नाही हा प्रॉब्लेम. Don't take easily, but it's a very much easier. It's a very much easier. See, that's why the result of NET examination is less. See, oh, see here, benzaldehyde, PH, C double bond O, H. This on reaction with sodium cyanide. That is benzoin condensation you have to do first. Okay. Benzoin condensation in the first step. MnO2, that benzylic OH group will get oxidized formation.
Hello. Hello. Shinte sir? Hello? Hello? Hello, dear participant. Shinte sir will join within 2 minutes. I want to pass some instructions. Our feedback link will be provided in the chat box only after completion of the vote of thanks at the end vote of thanks concluding. And if you want to give the feedback, tell me your names so that I will announce your name here. Your name with your college. Okay. Shinte sir will join within 1 or 2 minutes. Okay.
What's this? Hello?
Yes. Welcome, sir. You are audible.
Yes, yes, yes. Yeah, we were talking about, am I audible now?
Yes, sir.
Yeah. We were talking about this particular transformation, that is conversion of benzaldehyde to benzaldehyde to benzoin and benzoin to benzylic acid rearrangement. See, benzoin to benzyl and benzyl to benzylic acid rearrangement formation takes place over here. Just 1 minute. Yeah, one of the important reaction, many times it was asked in the NET examination. Just we can have that transformation. Some aromatic aldehyde is there. We can have benzaldehyde, and it was substituted by means of fluorine and chlorine. And on arrow, that is methyl acrylate, CO2Me, methyl acrylate, in presence of, see, this is the first reaction condition in presence of DAPCO, and second step is benzylamine, BNNH2, benzylamine is there. Okay, and see, can you tell me the name of this reaction? The name of first reaction. But meantime, I will write the structures of the products, whatever structures are given. Okay, this is the fluoro. Meantime, you can write in the chat box, the students here, OH, CO2 ET, sorry, CO2Me, not ET, here NHBN, second one FCl, here OH, CO2Me, third one F, this Cl, NH, Bl, here double bond and CO2Me, and fourth one this FCl, N, CH2PH. Okay, and here OH and CO2 Me. Okay. Chat box. Yeah, what will be the answer? Yeah. Yeah.
Number 1 is given.
Yeah. 1. Yeah. Yeah. Somebody is
Given.
2 is given. 1 is given. Yeah. Okay. See over here. Why not 2? 2 is the intermediate. Or 2 is the product of first step only. 2 is the product of first step. And 1 is the answer of final steps. Okay. Are you getting this point? The name of this reaction is a Baylis-Hillman reaction. Baylis-Hillman reaction, or sometimes it is called as Morita-Baylis-Hillman reaction. And one of the scientists, professor from India, that is Basavaya from University of Hyderabad, he has contributed a lot in this particular reaction. That's why it becomes Baylis-Hillman-Basavaya reaction. Reaction of aromatic aldehydes with alpha beta unsaturated compounds in presence of tertiary amines. This is a tertiary amine. It may be DAPCO, it may be DBO, such type of amines. And the mechanism, those who have studied this particular reaction, Baylis-Hillman reaction, they know how first step is the aza-Michael addition reaction, and whatever carbon ion is there, that will attack on carbonyl carbon of aldehyde. And then elimination reaction takes place, formation of such type of product first. Means allyl alcohol formation takes place over here. And this allyl alcohol reaction with benzylamine. See, this is just aza-Michael addition reaction takes place over here. That's why formation of this particular product. Okay, with this, I can stop over here because from 2 o'clock we are discussing a lot of difficulties which I have faced, and I could not able to give 100%. Just a temporary arrangement I have made over here. Otherwise, if my tab is working, then straight away we could have been discussed a lot of things with you. Okay, once again, I am very much thankful to all the coordinator or organizing committee of this particular workshop organized by this Shivaji College Amravati. Special thanks to Thakre madam, because she has invited me and giving me an opportunity to share my views regarding multi-step organic transformations. Okay, it's a huge topic, and you have to know n number of reagents, n number of reactions, n number of rearrangements. Then only you can able to solve such type of problems. And for that, lot of dedication, lot of devotion is required, not only from the faculty but also from student community. Also, you have to read the quality books. Then only it is possible. Okay, with this, I want to give you best wishes for your future career, and definitely you may succeed in the competitive examinations like NET, SET, and GATE examination. Thank you one and all.
Thank you, sir. Just a minute.
Very good evening to all the participants who are present for this CSIR NET/SET examination workshop 2021. I, Dr. Vandana Khobragade, have great pleasure and honor to propose the vote of thanks on behalf of the organizing committee of CSIR NET/SET examination workshop 2021 to our guest speaker, Dr. Shinte sir. Sir, on this wonderful day, we are so lucky to have you as a guest speaker for this workshop. Sir, you have introduced many of the things today. You have introduced students to the grandfathers of the chemistry, Nobel laureates in the chemistry. Sir, your guidelines about the preparation of CSIR NET set examination is really helpful to the NET set aspirants. You have realized, students, that reading quality books is very necessary for cracking the exam. Listening the lectures of the experts in chemistry is also very essential. Self-study, group discussion is the most important here. Sir, mantra that you have given today, that coming together is beginning, keeping together is progress, working together is success, will surely motivate our students. I especially thank Dr. Shinte sir that he has taken many of the problems and conduct very interactive session. Sir, today you have given very nice exercise on the organic transformation reaction and make the students think more and more. I wish to express my whole gratitude towards Dr. Vapurao Shinte sir for giving his valuable time, which makes this workshop session successful. Thank you so much, sir. Now, I invite Dr. Yogita Thakre ma'am for the next proceeding of this workshop.
Thank you, sir. We have a feedback from the student participants, and lastly, the whole concluding vote of thanks. Okay, so be with us for a few more minutes, sir. I request you, sir.
Okay. Just after 2 minutes, I will join it. Just one.
Okay, sir. Okay, no problem. Now, dear participants, it's time for a feedback. So I will call Rupali Muksaji Maharaj Mahavidyalaya, Darwa.
Good evening and good evening, friends. Madam, I just want to give a lot of thanks to your college that they organize a very such informative workshop for us. As we all of us knows that CSIR NET and SET examination is very tough and it is very essential to crack if we want to achieve the post of associate professor in the college. And this examination is really very tough as per my information. And today, due to this workshop, I got the knowledge how to crack this examination, and this workshop act as a catalyst for for the study of NET and SET examination. So I like to give a lot of thanks to host and co-host, and also give the thanks to my dear friends who attend this workshop, and also want to give best wishes for you to manage this kind of workshop for our the student like us. Thank you so much.
Okay, definitely. And thank you, dear Rupali. Now next, the Kuldeep R. Ingre, a student of MSc second year, Shri Shivaji Science College, Amravati. Please, Kuldeep. Kuldeep, please unmute yourself. You are not audible. Kuldeep, unmute yourself. Kuldeep, unmute yourself. Kuldeep, are you there? The next participants I call upon Aarti Rao Sahib Pagare, Modern College, Ganesh Khen, Pune. Aarti, please. Aarti, are you attending the session? Aarti. Aarti, am I audible? Am I audible, dear participants?
Yes, you are audible, ma'am.
Yes. Okay. So next, Shubham Davande from Shri Shivaji College, Akola. Shubham Davande. Shubham Gavande. Are you there in the session? Shubhangi Mote. Shubhangi. Are you there in the session, Shubhangi? Shubhangi Mote, Solapur University, Solapur. All the participants given their name for a feedback, live feedback. So next I call upon Swati Kadu, Art, Commerce and Science College, Satarad. Shubhangi Kadu. Sorry. Yes. Next is Samiksha Gulakshe, GS Tompe College, Sandur Bazar. Samiksha, are you connected here? Okay. Kuldeep, have you joined the session? Kuldeep.
Yes, ma'am.
Okay.
Ma'am, आवाज येता माझा?
Yes, yes, you are audible. Start.
Okay. Good evening, one and all. Myself, Kuldeep Ranjit Ingde, MSc second year from Shri Shivaji Science College, Amravati. First of all, I would like to thank to our head and our principal of our college, Dr. G.N. Chaudhary sir, and also would like to thank to our convener of this workshop, Dr. P.R. Mandlik sir, organizing secretary, Dr. Yogita Thakre ma'am, and also organizing committee members, Dr. V.B. Khobragade ma'am and Dr. R.D. Bankar ma'am. And thanks to today's guest lecturer, Dr. Bapurao Shingate sir, for delivering this today's lecture along with his basic guidance on NETSET examination preparation, along with his correct reference which how to use to prepare to competitive examination. It's my personal experience that today's lecture of Dr. Shingate sir was best lecture among the lecturers. I have attended and I have attended. I thank you, sir, for guiding us so nicely. And I would thanks to each and every student of this workshop, enrich his knowledge, and definitely they have get proper direction. I thank you so much, sir.
Okay, thank you, Kuldeep. John F. Kennedy rightly said, as we express our gratitude, we must never forget that the highest appreciation is not to utter words, but to live by them. So, good evening, one and all present here. I pay my tribute to late Dr. Panjabra alias Bausaib Deshmukh, founder president of Sri Shivaji Education Society, Amravati. The wings of time seem to have flapped with a great speed. And here are that end of the workshop. On this wonderful evening, I, Dr. Yogita Sahibrao Thakre, organizing secretary, here to propose a oath of thanks for online 2-day workshop on CSIR NETSET examination for postgraduate students offering chemical science, organized by PG Department of Chemistry, Sri Shivaji Science College, Amravati. I hope the dear participants enjoyed this workshop. We, the organizer, extend our sincere thanks to Honorable Chairman, Chief Guest, distinguished speakers, and my dear participants. I deem it a great honor and privilege to propose vote of thanks on this memorable occasion. On behalf of the organizing committee, I wholeheartedly thank respected Dr. G.N. Chaudhary, officiating principal, professor, and head, Department of Chemistry, Sri Shivaji Science College, Amravati, for chairing the inaugural function of workshop and for its constant encouragement, support behind organizing such valuable workshop. Thank you, sir. But take this golden opportunity to thank Dr. F.C. Raghuvanshi, Dean, Faculty of Science, Santa Gadge Baba, Amravati University, Amravati, for gracing the event as a chief guest and as an inaugurator for the workshop. We will try our best to cultivate your advice whatever you gave us. Thank you, sir. I'm grateful to Dr. A.S. Aswar, Professor and Head, PG Department of Chemistry, Sant Gadge Baba, Amravati University, Amravati, for sparing his valuable time, for giving insight on this occasion, and for your inspiring speech. Thank you, sir. It's my pleasure to express thanks to our distinguished guest speakers for accepting our invitation and delivering very informative lectures on various topics and guiding students. All the speakers really have taken efforts to explain basic concepts and idea about examination pattern. Also, during this session, they have given emphasis to develop skill to qualify NET and SET examination. Our first speaker for first session on 25th August 2021 was started with the young and dynamic speaker, Dr. Manishri Rao, ex-assistant professor, Department of Chemistry, Modern College, Pune, Director, R&S Academy for CSIR NET SET GATE examination, Pune. Deliver a talk on introduction to NET SET exam and stereochemistry. For the post session, we have eminent speaker, Dr. Vikas Dikadu, Assistant Professor, Department of Chemistry, School of Chemical Science, Punyashlok Ahilya Devi Hokar, Solapur University, Solapur, deliver a lecture on reagents in modern organic synthesis. On second day of the workshop, 26 August 2021, the session was started with the graceful lectures of Dr. Anand Burenge, Assistant Professor, Wilson College, Chowpatty, Mumbai. Nicely explained very important topic, reagents in modern organic synthesis. And for the post session, we have a very energetic and inspiring speaker, Dr. Bapurao B. Shinte, Associate Professor, Department of Chemistry, Dr. Baba Saheb Ambedkar, Marathwada University, Aurangabad, who deliver a lecture on multi-step organic transformations. Definitely, this knowledge is going to have very fruitful results. Thank you very much to all expertise speakers. Our special thanks goes to Dr. Meghsham Patil, Assistant Professor and Head, Department of Chemistry, Dr. Baba Saheb Ambedkar, Marathwada University, Subcampus Usmanabad, for providing this eminent speaker to us. Thank you, Meghsham. Our sincere thanks goes to Dr. Dinesh Khedkar, Professor, Department of Botany, Shri Shivaji Science College, Amravati, for his technical support and help. Without his cooperation, it could not possible to handle this online platform. Thank you, sir. I'm also thankful to organizing committee for providing this online platform for the postgraduate student to face the CSIR NET SET examination by organizing such time-demanding workshop. Convener, Dr. Prashant Mandlik, committee members, Dr. Vandana Khobragade and Dr. Raki Bankar. Thank you to all. I sincerely thank all teaching and non-teaching staff members of Department of Chemistry for contribution, guidance, and encouragement, and for glorifying this function. Last but not least, I'm thankful my dear student participants for their active involvement and for attending this workshop with a keen eye and enthusiasm. Without you, function could not be a success. Once again, on behalf of the organizing committee, thank you one and all wholeheartedly who work behind the screen to make this event to a resounding one. Thank you. Thank you one and all. Thank you, sir. Thank you, sir. Okay, thank you, sir.
Thank you, sir.
Thank you. The feedback link is in the chat box. You please fill the feedback. It will open up to the 12 a.m. today. Okay, and after that it will be closed. Okay, so certificate will provide it to those students who fill the feedback link. Thank you, sir. Thank you very much to each and everyone.
Thank you, ma'am.
Okay, now you can leave the meeting. Okay. Okay, thank you, one and all.
बंद करना नहीं बेटा चला आता एक प्रोग्राम करावा लागेल ना आपल्याला सांस्कृतिक प्रोग्राम
व्हॉइस कोणाचा सुरू आहे बंद करा
नाही